This is Mission Control, Houston, at 5 hours 24 minutes mission elapsed time. Discovery now on the descending node of orbit 4 as it crosses over the South American continent. Discovery currently in a 330 by 311 nautical mile orbit, circling the Earth every 96 minutes 43 seconds. The crew now, as the cabin is down to 10.2, is beginning preparations for the checkout of the extravehicular mobility units, or the spacesuits that would be used in the event that a spacewalk would be necessary. Everything so far in the timeline has gone very smoothly, including checkout of the remote manipulator system arm and depress of the cabin down to the 10.2 psi level. We're now at 5 hours 25 minutes mission elapsed time. This is Mission Control, Houston.
Houston Discovery, we've completed the tags activation.
Okay, Bruce, we copied that. We'll have a test message to send up to you in a while.
Yeah, 18 pages through, and it seems to be working fine, and the paper's coming out white now. And I think you're right on that overheat being transient, because the overheat light is now out and hasn't come back on.
Okay, that's good news. We'll have a test message to send to you in just a few minutes. We'll give you a warning.
Roger that.
Yeah, Bruce, that'll be about a half an hour before we get back into comm for it, so we'll let you know. Discovery, Houston, we had given you the go for in the Hubble deploy to do step 3, the transfer to HST main bus power. We didn't hear if you had completed that step or not.
Houston Discovery, that's affirmative, Jim. Main bus activation is complete.
Okay, thanks.
And I'm sorry, I misspoke. The transfer of the heaters over is also complete.
Roger, thank you.
And Jim, for the Earth Lab skies and your benefit, I got to tell you, I just made it up to the flight deck for a first look out the window, and 330 is a whole lot higher than 120 was, and ever how much longer it takes you to get here, every second of the wait is worth every second that you get.
We're glad to hear you're enjoying the view, Kathy. Discovery Houston, I have a couple of bits of information while you're finishing up lunch. On Steve's question about the backup release time, this is a -7 end effector, a new one, and we have seen some increased times during testing of 10 to 11 seconds, so we expected the higher times. HST, the POC has been communicating with HST, and they have completed OTA bus activation. We think that probably the UHF comm problem we had earlier was due to a ground problem at Vandenberg. When we get to IOS in a couple of minutes, we're going to have you give us some more comm checks. I'll get back with you on that one. And then if you have some time, we have a few switches for you on panel R2.
Charlie says he's ready. Go ahead.
Okay, Charlie, on panel R2, we'd like for you to take boiler controller / heater 2 to alpha, and then boiler power 2 to off.
Charlie says that's done.
And one more for him there, APU fuel pump / valve cool Bravo to off to finish up your APU cool off. Okay, thanks, Discovery.
And Houston, I was looking ahead, and I think in the cap we've got a playback of the HST inspection scheduled. I don't know how much of that you saw live and how much of it you might want to see again, or something you missed. And if you saw that you want to see, we're trying to set up something else for you.
Okay, Steve, we'll check and get back right with you.
I got about 2 tapes worth of inspection stuff, but I expect you saw most of it.
Discovery Houston, for Steve, It looks like we saw everything that we needed for the HST inspection except the part that you did during your RMS checkout. If you could queue up that part of it and show us that, they'd be happy.
I don't think I understood that, Jim. Say it again.
Steve, we think that we got all of the HST inspection except for the part that you did during the RMS checkout when you were maneuvering the arm around some at that time. If you could show that part again, that's all we need.
Okay, let me try this. RMS checkout and HST inspection with the RMS, the way I did them were two separate events. I assume you don't want to look at RMS checkout. You want to see some of the inspection that was done using the end effector camera?
That's correct, Steve.
Okay, I got about 45 minutes of that stuff. Do you care what you see?
Yeah, Steve, we think we missed all of that part of it. If you could just start at the start, and we'll watch that. If we get to a point where we've seen it, then we'll let you know.
Ah, okay. I guess I thought you guys were watching while we were doing that, so we'll set that up.
Yeah, Stephen, we did watch all of it that we could receive. Just sometimes we weren't in coverage and we missed parts of it.
Okay, no problem. We'll queue it up.
In Discovery, we now have iOS UHF. We'd like for you to do a comm check if you can from two separate ATUs.
Houston Discovery from the MS ATU. How do you read?
We have you loud and clear, Steve.
Okay, stand by. And Houston Discovery, how do you read from the PLP ATU?
Okay, Steve, we had just a little bit of hiss on that one, but it was still loud and clear. We'd like for you now, if you would, switch back to Audio Center 1 and then give us another comm check from any station at all.
Houston Discovery, radio check from the MS ATU on Audio Center 1.
And you're loud and clear. That sounds good from that one also. I think we've narrowed it down to Vandenberg has a problem, and we'll let you know if we find out anything different from that, Steve. Thank you. Discovery, Houston, we're going to lose TDRS, but we'll have iOS UHF for another 4 or 5 minutes. We'll be back with you on TDRS at 6 hours even.
This is Mission Control Houston at a mission elapsed time of 5 hours 59 minutes. We're about 1 minute 10 seconds away from acquiring signal with Discovery through the Western satellite. As we passed over the Indian Ocean ground station, we did another communications check through the UHF circuit with the crew, and that went very well, which seems to verify that the problem on the UHF circuit was isolated to the Vandenberg ground station.
Discovery, Houston, back with you on the West satellite.
You're loud and clear, Jim.
And we have you loud and clear. Discovery, Houston, we have your first tags message coming on board, and it's not just a plain old test message. This is your predicted TDRS West longitude for the Spock, so Kathy can load that in and get it correct.
Roger, Jim, we copy that, and we'll be looking for it.
Roger.
This is Mission Control Houston. That call to the crew to let them know that their first message would be sent from the ground to the text and graphics system, which earlier was showing a overheat on a temperature reading. That has since been corrected here on the ground and was observed to be a transient. And Mission Specialist Bruce McCandless reported that he had sent 18 pages through the tags without any errors or jams, and therefore the tags is considered operational. And the first message from the ground to the crew is in the process of being sent. That message is for Mission Specialist Kathy Sullivan to update her shuttle payload onboard computer, or SPOC, which is used to, in this case, to load the TDRS, the amount of tracking we're allowed on the TDRS satellites.
And Houston Discovery, tags message received. It's looking good.
Well, we're glad to hear that, Bruce.
This is Hubble Telescope Control Greenbelt at 6 hours 12 minutes mission elapsed time. We've regained our command capability with the Hubble spacecraft and have just completed sequence 3, which is the activation of the optical telescope assembly's thermal control system. The control team is now in the process of sending commands to activate the control unit and science data formatter. This is a redundant box that is at the central hub of the command and data handling system for all of the scientific instruments. The current series of commands is expected to take about 5 minutes, at which point the activation of the actual scientific instruments, those 5 scientific instruments that make up the Hubble Space Telescope, that activation will begin following this sequence. At 6 hours 13 minutes mission elapsed time, this is Hubble Telescope Control Greenbelt.
Houston Discovery.
Go ahead, Discovery.
Did you guys want to look at the videotape dump now?
Stand by just a minute, Steve. We have to configure. Discovery Houston, Steve, we're ready for you to send the VTR playback to us. And for information, we're sending a new orbiter state vector up in just a minute, and also your target load, and we'll have your burn pad in just a couple of minutes.
Roger, Houston, we copy that.
Discovery Houston, I have your maneuver pad when you're ready to copy.
Okay, Jim, stand by just a second. Okay, Jim, we're ready to copy the pad.
Okay, Lauren, this will be your maneuver pad to circularize your orbit. It's RCS plus X. TV roll is 180. Trim load is NA. Weight 231534. TIG 00/0709:15.3. Peg 7 targets, delta VX plus 033.4. Delta VY is all balls. Delta VZ plus 002.4. Your maneuver attitude, roll 293, pitch 172, yaw 325. Delta V tote 033.5, T-go 02:17, Vigo X plus 032.85, Vigo Y is all balls, Vigo Z plus 006.48. Target HA is 332, HP plus 331. Your notes are all NA or none. Over.
Okay, Jim, let me give you a read back here. It's RCS, a plus X, TV roll 180. Trim load not applicable. The weight is 231,534. The TIG is 0 slant 07:09:15.3. The peg 7. Delta VX plus 033.4. Delta VY all balls. Delta VZ plus 002.4. Maneuver attitude, roll 293, pitch 172, yaw 325. Delta V tote 033.5, T-go 02:17, Vigo X plus 032.85, Vigo Y all balls, Vigo Z plus 006.48, the target HA 332 plus 331 for HP. The notes are NA or none.
That's a good readback, Lauren. Discovery Houston, we're just wondering if you could give us a status on your EMU checkout.
And Houston Discovery, that's in work now. And standby will get you a point where they're at. I think they just got started a little bit ago.
Okay, thanks, Lauren.
This is Mission Control Houston at a mission elapsed time of 6 hours 30 minutes.
Discovery Houston, just to keep you informed, the stock is currently activating the science instruments.
Okay, Jim, we appreciate that knowledge.
Discovery Houston, you should have a teleprinter test message on board, and when you get an opportunity, we'd like to have a status on that, please.
Roger, Jim.
This is Mission Control Houston. The burn pad for the upcoming reaction control system burn of Discovery was read up to the crew a few moments ago. That burn will occur at 7 hours 9 minutes 15 seconds mission elapsed time, and that will circularize Discovery's orbit at 332 by 331 nautical miles. That burn will last for 2 minutes and 17 seconds, and the delta V or delta velocity total will be 33.5 feet per second.
And Houston Discovery, unless you have a problem, we'll go ahead and get into the burn procedure and go ahead and maneuver on over to the attitude.
Yeah, we're checking the attitude right now, Lauren.
Roger.
Discovery Houston, Lauren, we would prefer that you stay in your current attitude and do it on time if possible to ensure that we keep our KU coverage good for this VTR playback.
Roger.
And Jim, do you have an approximate time it's going to take us to maneuver over there?
We'll get that for you, Lauren, and be right back with you. Discovery Houston for Lauren. It looks like your maneuver will take about 12 minutes, Lauren, and we think if you wait until an MET of 6:45, that'll give you about 24 minutes or so, so that should work out okay for both things, for the TV downlink as well as your maneuver.
Okay, we copy.
Discovery Houston, we have Vandenberg UHF for just a little bit longer. We'd like one more comm check from any ATU with UHF.
Okay, Jim, we're plugged into MS ATU on the speaker mic, and this is a comm check for UHF.
Okay, Lauren, thanks a lot.
How was it?
We just found out we did not get any UHF that time, Lauren.
Roger that.
It looks like we got good UHF when we were over Mila and iOS, and we had hoped that we had resolved the problem, but because Vandenberg said they were getting UHF down, but it looks like we didn't get it that time.
Okay, we copy. And Houston Discovery, we reached the end of one tape, and I can rewind the next one and put it in there, but we may be about out of time. You want me to save it till later, or you want to try to take some more now?
Stand by, Steve. Discovery Houston, Steve, it looks like after checking that our attitude will be okay even after you maneuver, so we could get another 10 or 15 minutes worth if you'd like to show that now.
Okay, Jim, we'll do it.
Thank you.
This is Mission Control Houston. Report from the ground is that Discovery is in the burn attitude for the reaction control system burn, which will circularize Discovery's orbit at 332 by 331 nautical miles. That burn is scheduled for 7 hours, 9 minutes, 15 seconds mission elapsed time. That's about 10 minutes from now. And that burn will change Discovery's velocity by 33.5 feet per second. Also, the EVA officer, the extravehicular activity officer, reports that the EMU, or extravehicular mobility unit checkout, which is in work aboard Discovery, is going very smoothly, and the fan operation is in work aboard those suits.
This is Hubble Telescope Control Greenbelt at 7 hours, 4 minutes mission elapsed time.
Houston Discovery.
Go ahead, Discovery.
The L3A just now changed to a leak notation.
Roger, Lauren. We saw the oxidizer injector temperature drop. We are go for the burn, and we'll continue to look at it.
We copy, Jim.
Houston Discovery.
Go ahead, Discovery.
Yeah, Jim, the EVA guys, for info, we're on page Alpha 4-3, complete on EMUs 1 and 2 through the end of the fan regulator check. We're taking a break here at the comm checks. And another topic, call center test message received, and all okay.
Okay, thanks a lot, Kathy.
This is Hubble Telescope Control Greenbelt. Activation and verification of the Hubble Space Telescope hardware and equipment has been going very well over the past few minutes. The control team here in Greenbelt, Maryland, as well as engineers and the support team at the Huntsville Operations Support Center in Huntsville, Alabama, are currently looking over those systems. We have completed activation and verification of 4 of the 5 scientific instruments, those being the faint object camera, the wide field planetary camera, the faint object spectrograph, and the Goddard high resolution spectrograph.
Discovery Houston, we're losing our VTR playback now. You can stop that and we'll finish up if we need any more later. Thank you, Steve.
Roger that, Jim.
We have about 9 minutes remaining in what is called a zone of exclusion, or a period of time in which we lose command capability with the spacecraft. We've been in this ZOE for some 12 minutes or so now. We'll be coming out of that at mission elapsed time about 7 hours 16 minutes. And at that time, we will pick up the activation and verification of the 5th and final scientific instrument, that being the high-speed photometer. At mission elapsed time 7 hours 7 minutes, this is Hubble Telescope Control, Greenbelt.
This is Mission Control Houston at 7 hours 9 minutes. We're standing by for the RCS burn to circularize Discovery's orbit. And the propulsion officer reports that the burn is in progress and looks good. About 30 seconds now remaining in the burn.
And Houston Discovery, we did the burn and we cut off at a 332 by 331.
Okay, Lauren, that sounds good.
And this is Mission Control Houston. The crew reports that the burn is complete. Discovery is now in a 332 by 331 nautical mile orbit. No major burns are remaining until after the telescope is released from Discovery's robot arm, and that will be tomorrow afternoon. With the change in velocity and the change in altitude now, Discovery's period is now 1 minute 37 seconds, and the correction, the current orbital period is 1 hour 37 minutes 3 seconds.
This is Hubble Telescope Control, Greenbelt at 7 hours 16 minutes mission elapsed time. We're standing by here in the control center to regain command capability with the spacecraft and to complete the sequence which will activate the high-speed photometer, that 5th and final scientific instrument on board the Hubble Space Telescope. The activation and verification of the first 4 scientific instruments went very well. A poll of the consoles here says that all instruments are looking nominal, and activation and verification of the Hubble Space Telescope going very well at this time. At mission elapsed time 7 hours 17 minutes, this is Hubble Telescope Control, Greenbelt.
Houston Discovery.
Go ahead, Discovery.
Yeah, Jim, we're starting into the comm checks on page A, Alpha 4-3 and EVA checklist, so you guys are going to see the UHF go to EVA.
Okay, Charlie, thanks.
Okay, Bruce, how about going to backup, receive PTT, and Kathy, you go to backup, receive PTT. Okay, and I hear it coming up slowly. How do you guys read me?
Okay, yours is much better, Kathy, but yours is very readable, Bruce. Okay, Bruce, go to B, Vox, and Kathy, go to A, Vox, and I'm going to 296.8.
And Charlie, you're coming down on air to ground now, too.
Yeah, it's very good, Bruce.
Discovery Houston for Charlie.
Yeah, go ahead, Jim.
I just wanted to make sure you heard you were coming down on air to ground while you were talking to Bruce and Kathy.
Okay. Okay, got you loud and clear, Bruce. And how about you, Kathy? Got you loud and clear. And if we can get Bruce, you go to AVOX, and Kathy go to BVOX. Okay, how about now? I was pressing the wrong button. 5, 4, 3, 2, 1, 2, 3, 4, 5. And how do you read, Bruce? I got you 5 by. You can both go back to hardline and then dock the comm carriers. And Houston Discovery, the comm checks are complete. We had everything working well.
Roger, copy. We copied that, Charlie. Thank you.
This is Mission Control Houston. The Capcom Jim Voss and pilot Charlie Bolden had a conversation about the communications checks on the extravehicular mobility units that are being checked out by mission specialist Kathy Sullivan and Bruce McCandless aboard Discovery. The report was that those comm checks went well with no problems.
This is Hubble Telescope Control Greenbelt at 7 hours 26 minutes mission elapsed time. Our next television event will be an orientation from the Space Telescope Operations Control Center at the Goddard Space Flight Center here in Greenbelt, Maryland. That activity sent to air at 3:10 p.m. Central Daylight Time. That activity will be followed by a tour of the Huntsville Operations Support Center at Marshall Space Flight Center in Huntsville, Alabama. A technical support team at Marshall is assisting the controllers here at the Space Telescope Operation Control Center with the orbital verification of the Hubble Space Telescope. At 7 hours 28 minutes mission elapsed time, this is Hubble Telescope Control Greenbelt. This is Hubble Telescope Control Greenbelt at 7 hours 36 minutes mission elapsed time. We're now receiving television from the Space Telescope Operations Control Center here at the Goddard Space Flight Center in Greenbelt, Maryland. The first phase of the process of activation and checkout of the Hubble Space Telescope is the responsibility of the orbital verification team, which is composed of members from the Marshall Space Flight Center in Huntsville, Alabama, the Goddard Space Flight Center here in Greenbelt, Maryland, and the European Space Agency, as well as key telescope contractors. The Space Telescope Operations Control Center, or STOC as it's known, here in Greenbelt is the focal point for this orbital verification activity. Representatives from each of the organization's staff, the control facility here around the clock.
Discovery Houston, I have a switch for you on panel A7.
Go ahead, Jim.
On A7 lower, I'd like you to take the MADS strain gauge to PCM enable We've just seen the temperature going up a little bit, and we'd like to have it cool down. We're going to be LOS from the TDRS in about a minute or so. We'll continue to have IOS UHF for another 5 or 6 minutes, and then we'll be back with you on the other side at 7:45.
Roger that.
The Marshall Center orbital verification has the overall responsibility for activation and checkout, and makes the final go or no-go decisions for each step of the activation process. He is supported by a team of engineers, both here in Greenbelt and in Huntsville, Alabama. They continuously monitor the status of the telescope and identify and help resolve any problems should they develop. The actual commanding of the telescope is accomplished by the Goddard Space Flight Center's mission operations contractor, which is Lockheed Missiles and Space Company. The heart of the Space Telescope Control Facility is the mission operations room. Here, console operators for each of the telescope's major systems will validate commands being sent to the spacecraft and will verify that the commands have had the desired result. This team, which occupies a horseshoe-shaped set of consoles in the control room, includes experts on the science instruments and the science instrument computer, as well as the optics, the pointing control system, the data management and instrumentation and control subsystems, and the electrical power and thermal control systems. Commands are actually built and sent to the spacecraft by the operations controller. This operations controller shares a console in the center of the horseshoe with the shift supervisor. The entire mission operations contractor team reports to this ship supervisor, who in turn is responsible to the Goddard Mission Operations Manager, or MOM for short. At the rear of the control room is a set of consoles occupied by members of the Marshall Center's Orbital Verification Management Team. These consoles include the interface between the Director of Orbital Verification and the analysis teams in Huntsville, Alabama. The team here at Goddard has confirmed that we have now completed all activation of the 5 scientific instruments aboard the Hubble Space Telescope. The activation and verification of systems going very well at this time, and we're standing by now for a switch of television to the Marshall Space Flight Center in Huntsville, Alabama. This is Hubble Telescope Control in Greenbelt, now receiving television from NASA's Marshall Space Flight Center in Huntsville, Alabama, where a team of technical experts is located in the Huntsville Operations Support Center there to monitor the Hubble Space Telescope's engineering performance during this orbital verification period. In tracking the telescope's status and engineering performance, the Marshall Technical Support Team has 3 major assignments. First, they will monitor telescope telemetry, tracking several thousand engineering measurements to determine the ongoing status of the telescope and confirm whether the telescope has responded properly to the ground commands. With this information, the team can also identify any problems should they arise. Secondly, the Marshall team members will use their in-depth knowledge of the telescope and its systems to analyze any problems and recommend solutions. This will include both problems identified by controllers here in the Space Telescope Operation Control Center in Greenbelt, and then assigned to the Huntsville team for analysis, as well as those discovered by the technical support team and reported to the Greenbelt controllers. The third responsibility is that the Marshall team will evaluate the performance of the Hubble Space Telescope during this orbital verification to determine its true capabilities and project future performance. In carrying out these responsibilities, the Marshall Technical Support Team in Huntsville, Alabama, is organized by specialty into subsystem teams. This is opposed to being grouped by individual agencies and or companies. The team members include both the NASA and contractor employees with expert knowledge of their particular Hubble Space Telescope subsystem. Each of the teams is led by a NASA engineer, which is charged with accomplishing the three support team goals. The engineering specialists from the various companies which develop the system are also a part of that team. Each of the discipline or subsystem teams will continuously monitor real-time data, which is telemetry that is currently being sent from the telescope. The current value of hundreds of different measurements concerning their assigned subsystem will be displayed on their computer screens. Some of the types of measurements that they'll be tracking are things like temperatures, velocities, time, position, and various currents and voltage. Each of these measurements has been assigned what is called a safe limit for every stage of the activation and the operation of the telescope. For instance, at any stated time, a designated heat sensor should register a specified temperature. If that measurement begins to move outside its safe range, the screen it appears on will flash yellow to indicate that a potential problem is there. If the limits are passed then even further, the screen will flash red. Additionally, about 200 measurements may be identified as critical for any point in the activation or operation. When these approach the limits, a message will flash on all the terminals regardless of the discipline. Once a problem has been identified, the discipline teams will go into action to track down the cause. First, they'll determine if there is a real problem in the telescope itself, or if computer software is showing an erroneous measurement. If the problem is with the telescope, an approach to resolving it will be formulated between the Marshall Technical Support Team and the management group in the Space Telescope Operations Control Center here in Greenbelt. Contingency plans designed in advance for dealing with possible problems would be reviewed. The discipline teams will analyze current and past data from the telescope as well as the design records. Based on that research and their in-depth knowledge of the subsystems, the teams would then recommend a solution. The support team in the Huntsville, Alabama Support Center consists of some 175 team members. Again, these team members represent both NASA as well as contractor personnel. They include personnel from the Marshall Space Flight Center, Lockheed Missiles and Space Company, the Hughes Danbury Optical Systems, and the European Space Agency. The Space Telescope Operations area in the Huntsville Operations Support Center will be operating around the clock, as will the Space Telescope Operations Control Center here in Greenbelt, Maryland, for the total orbital verification period. At this time, the activation of the systems aboard the Hubble Space Telescope continues to go well. We are currently in a zone of exclusion period in which we do not have command capability. We expect to regain command capability at a little after 8 hours, 20 minutes mission elapsed time, and at that time we'll begin to activate, dump, and verify the DF-224 computer, that is the main computer aboard the Hubble Space Telescope. All 5 of the scientific instruments have been activated and verified at this time, and all goes well with the activation of the Hubble Space Telescope. At 7 hours, 48 minutes mission elapsed time, this is Hubble Telescope Control, Greenbelt.
Discovery.
Go ahead, Discovery.
Okay, Jim, the lamp test went without anomaly. On the fire smoke detection suppression test, the circuitry is okay. The only problem is on System 1, the left and right flight deck 2 Bravo parameter there is reading minus 0.8 and the limit is minus 0.1. And in fact, it fluctuates between minus 0.7 and minus 1.0.
Okay, Charlie, we copied that. Discovery, Houston, for Charlie, concerning your fire smoke detection test, that parameter that was out of limits, we don't have a good explanation for it yet, but we'll continue to look at it. We don't think there's any problem right now.
Okay, thank you very much.
Discovery, Houston, for EVA, we see you've completed the EMU-3 checkout, and we think it's okay for you to terminate the battery charge on EMU-2 now.
Okay, Jim, I copy that, and you're right, we've just stopped EMU-3 and we're finishing up the temporary storage. I assume you do want me to power back up EMU-1 and let it finish its charge.
And Kathy, that's not required. You don't need to do that.
Okay, we have bus selects for both EMUs off this time.
Okay, thanks.
This is Mission Control Houston. That conversation confirms that all 3 extravehicular mobility units are fully checked out and are in perfect operating order.
And Houston Discovery, for the EVA guys, the quick summary is that all 3 suits check good, no anomalies, any test, and we have the data recorded on board.
Okay, Kathy, thanks. We concur from what we can see down here.
A few moments ago, pilot Charlie Bolden reported that the checkout of the smoke detection and fire suppression system went very well, other than a reading of a little bit out of parameters on 2 of those detectors. However, the environmental and communications officer, the environmental and consumables officer, reports that the small bias is at this time appears to be okay, and they'll continue to monitor that on the ground. All aboard Discovery continuing to go very smoothly as the orbiter is now headed out into the Pacific Ocean on orbit number 6. All has gone very smoothly with the activities scheduled for the day, and that included the checkout of the robot arm, which will be used to grapple the telescope tomorrow and hold it in a hover position while all of the appendages and solar arrays are deployed, and then release it from the arm once all of that has been checked out. The actual deploy is scheduled for about 1 day, 5 hours, 23 minutes mission elapsed time. That translates to about 1 p.m. Central tomorrow. Also completed was the depressurization of the cabin from 14.7 psi down to the 10.2 level. that to prepare the crew members for a spacewalk should that become necessary. And that cabin pressure.
Discovery.
Go ahead, Discovery.
Yeah, Jim, while I think about it, just a piece of anecdotal information also for the EVA guys. Discovery's Volume H opens with no problem at both cabin pressures. I de-stowed Volume H at 14.7 before we began the deepness, and just now finished putting the bag and the spare gear back down in Volume H, and there is no interference whatsoever with the mid-deck floor.
Okay, thanks. And the guys said they appreciate those words. We like those anecdotes. Discovery, Houston, Kathy, we have a switch for you to check in the airlock when you're ready.
Yeah, Jim, you can go ahead. I haven't done a final sweep on the switches, so you may well have caught us on something.
Okay. Yeah, when you go back through, just check and make sure that on AW18 Hotel, the power battery charger, EMU12 bus select, both of those switches are off, and the mode switches are both to power.
You got me.
Okay, thanks.
Also today, the main power bus was activated between the orbiter and the Hubble Space Telescope. That all went well, and all scientific instruments aboard the telescope have been powered on, and all of that has gone extremely well thus far in the flight. Also, the crew maneuvered Discovery to its final altitude, which will be used for the deploy of the telescope, and that is 332 by 331 nautical miles. That puts Discovery rotating the Earth every 97 minutes and 3 seconds. The crew has also supplied power to the ICBC, which is the IMAX cargo bay camera. That camera holds about 6 minutes of film and will be used during the deploy activities of the telescope tomorrow.
Discovery, Houston, for the EVA guys, we'd like to get some EMU numbers when you have an opportunity to read those back to us. When you're ready, I'll tell you which ones we would like. And just a heads up that we're planning on your PMC going on time in about 7 minutes.
Okay, Houston, we copy about the PMC, and we're still in the middle of a number of things here. We figured the EVA guys might like to hear some numbers eventually. Let us get back with you later towards pre-sleep, if that's okay.
Okay, Kathy, that sounds fine.
This is Mission Control. That discussion with Mission Specialist Kathy Sullivan pertaining to numbers that were gathered during the checkout of the 3 extravehicular mobility units. She reported those numbers are still being gathered and will be given to the ground in just a short while. In the meantime, pre-sleep activities are ongoing, and the crew is preparing for their private medical conference, which is a part of routine on the first 2 flight days. All activities have gone very smoothly today. In the timeline, one unresolved problem that occurred during ascent was the loss of an aft firing RCS, or reaction control system, jet, and the prop officer has been working that issue throughout the day. That jet has been declared failed off for the remainder of the mission. However, there are a number of RCS jets aboard Discovery that can be used for maneuvering and for deorbit and re-entry and landing. Other minor problems during flight day 1 earlier today was that the water supply on tanks C and D were about 10% difference between the two, which is usually not normal. That fluctuation is usually on the order of 3%. However, a troubleshooting measure was taken on the ground, and those two tanks are now within 2% of one another. Also, earlier today, the activation of the text and graphics system during that period of time, a heater problem was noticed by mission specialist Bruce McCandless, and the integrated communications officer performed some troubleshooting measures on the ground, and that tags is now working fine, and several messages have been sent to the crew from the ground. Also today, some UHF communications problems were experienced, and that problem seems to have been isolated to the Vandenberg site. However, the orbiter will not pass over that site again today, and they will likely try some UHF comm checks through Vandenberg tomorrow as Discovery passes over that part of the world. Other than those minor problems, no other orbiter systems problems have been reported. Everything performing very well aboard Discovery, and also aboard the primary payload, the Hubble Space Telescope, which was supplied power from the orbiter as the main bus was powered on earlier today. So everything appears to be shaping up very nicely for tomorrow's activities, which will include obviously the release from the RMS arm, or the remote manipulator system arm of the telescope, at about 1 day, 5 hours, 23 minutes, or roughly 1 p.m. Central Daylight
Discovery,
Time.
Houston, we're going to configure for your PMC now, and you'll be talking with the surgeon.
Okay, thank you.
Currently at a mission elapsed time of 8 hours, 35 minutes. This is Mission Control Houston.
This is Hubble Telescope Control Greenbelt at 8 hours 36 minutes mission elapsed time. The controllers here have begun the sequence to verify the data management subsystem, or the DF-224 computer on board the spacecraft. We have just come out of a rather lengthy time period where we were unable to issue commands to the spacecraft due to the configuration of the telemetry system. We now have that command capability back for about 30 minutes, and we'll begin this sequence to dump the memory of that main computer on board the spacecraft and compare it against ground computers to verify that the software is correctly loaded and that the computer is receiving commands and transmitting data properly. Again, this activity will take quite a while. We are expecting to enter another what is called zone of exclusion at about the 9-hour mission elapsed time, or less than 30 minutes from now, and then that zone of exclusion or loss of signal will last over an hour. But all is going well with the activation of the spacecraft thus far. At 8 hours 38 minutes mission elapsed time, this is Hubble Telescope Control Greenbelt.
Discovery Houston, we're back with you, and I have a switch for you to cycle for us on panel A7.
Okay, Jim, go ahead.
Yeah, it looks like that MAD's temperature is still up, so we would like for you to try one more time on the MAD's strain gauge. If you would, take that to on and then to PCM enable for us.
Okay, coming on, Mark, and back to PCM enable.
Okay, thank you. We'll continue to watch it. I've also got several flight notes for you concerning your pre-sleep activities and your COAS-CAL for later whenever you have some time to copy those.
Okay, stand by just one. Okay, Jim, go ahead. We're ready with flight notes.
Okay, Lauren, first of all, just a reminder to perform the 10.2 PSI cabin maintenance on page 6-7 of the contingency EVA checklist before you go to sleep. The next thing is your cryo config for your sleep period. This should be done after the fuel cell purge. On panel R1, O2, H2, manifold valve, tank 1, 2 switches closed. Then O2, H2, tank 2, heaters, alpha and bravo, 4 switches off. Then O2, H2, tank 3, heaters, alpha and bravo, 4 switches to auto.
Okay, so far we got doing the 10.2 cabin maintenance and for cryo config after the fuel cell purge. On R1, the O2 and H2 manifold valve tank 1, that's 2 of them to close. And then O2, H2 tank 2 heaters A and B, 4 of them off. O2, H2 tank 3 heaters A and B, 4 of those to auto.
That's a good readback, Lauren, and I have one other thing. It's a correction to page 3-9 of the flight plan when you've got that handy.
Okay, this will probably answer the COAS question that we were going to ask you.
Yeah, we thought there might be some confusion. Of course, you know that you're using the aft station for the COAS. In the COAS calibration log, we need to change some things there, and you may already have a change. This is yet another change. The star ID -Z, star 29 is Alcade. The star will be available from 08:56 to 09:48. And the star pair A1 attitude that you're going to is good for the COAS-CAL.
Okay, that did answer our question, and it'll be the same attitude as the COAS-CAL, or the IMU line attitude. And star pair, the star is -Z 29 Alcade.
That's affirmative, Lauren. And that's all I have for you right now. Thanks.
Okay, we copy.
Houston Discovery.
Go ahead, Discovery.
Tim, we're ready to give EVA the numbers they were after if you wanted to tell me what parameters they want.
Okay, Kathy. Basically, what they would like is from page A4-2, the numbers you took during your SOP check, the primary regulator check, and then on the next page from your leak check.
Okay, why don't you advise me when they're ready to copy?
They've got their pencils out right now.
Are they sharp?
And they've got lots of paper.
Okay, I'll give you EMU 1 and then 2 and then 3 for each parameter. Hope that's a relatively easy way for you. O2 pressure, 874 for EMU 1, 813 for EMU 2, 866 for EMU 3. SOP pressures, 6180, 6110, 6230. Interstage pressures, 300, 200, 300. Suit pressure with manual override depressed, 3.6, 3.7, 3.7, and the SOP interstage in step 4, 300, 200, 200. In the primary regulator fan and pump check, step 8, suit pressure in IV, decimal 8, and decimal 7. In press, 4.3, 4.3, and 4.3. Do you guys need the water temp and gas pressure, water pressure parameters? They were all in nominal range.
Okay, that's fine. We don't need those.
Okay, and this is exactly 180 out from an SMS session, step 11. 2-minute leak checks, all 3 suits, 0 delta P. I repeat, 0 delta P.
That sounds real good.
And going on down the list, step 18, input amps, 3.7, 3.9, or 3.6. EMU amps with the SCOF installed, about 2.7 on each of EMU 1 and 2, and 2.4 on EMU 3. Step 24, battery volts on battery power, 17.0, 17.2, 17.5. Battery amps, 2.7, 2.4, 2.3. RPMs, 19.3, 19.2, 19.3. And all the fans sounded real good with steady speed control. Over.
Okay, we got a good copy on all that, Kathy. Thank you for the good information.
Okay, and you probably noticed as we did the low amps on EMU 2 and 3 running on the battery, but everything looked fine to us otherwise.
Okay, and we concur. Sounds like you're ready to go if you need to.
That's how we planned it.
This is Mission Control Houston. Those words were downlink of all the numbers that were taken during the checkout of the extravehicular mobility units aboard Discovery. Mission Specialist Kathy Sullivan reported all of the numbers were within spec, and the EVA officer here in the flight control room concurred. And Capcom Jim Voss notified Kathy that it appeared that they were ready to go and do a spacewalk if that was necessary, and Kathy reported down that that's the way they had trained and planned it. The crew is now well into their pre-sleep activities. We're now about 2 hours and 1 minute away from putting the crew to bed after a busy flight day 1, including launch and checkout and activation of the main power to the Hubble Space Telescope. We're now at a mission elapsed time of 9 hours, 3 minutes. This is Mission Control Houston.
This is Hubble Telescope Control Greenbelt at 9 hours, 11 minutes mission elapsed time. We've been informed here in the control center that they have added some time to our command capability during this pass. We will not be losing that command capability until approximately 12 minutes from now, or at the 9 hour, 23 minute mark. So we are continuing with the checkout of the data management system, the confirmation of the DF224 computer program. That activity has been going on for some time and is expected to last for several more minutes. All is going well with the verification and activation of the systems on board the Hubble Space Telescope at this time. We will be continuing through with the data management subsystem verifications. Hopefully wrapping that up following this next loss of command capability somewhere around the 10-hour, 32-minute mark. At 9 hours, 12 minutes mission elapsed time, this is Hubble Telescope Control Greenbelt.
Houston Discovery.
Go ahead, Discovery.
Got some data on COAS Cal if you want it.
And Lauren, we have the data that we need. Thank you anyway.
Okay, thank you.
And Houston Discovery, we have completed CG activation. I imagine you already have the data on that also, over.
You'll probably have to give us that, Bruce, since we don't have any insight.
Okay, and looking at the rim up here, you know, it's a 22 degrees centigrade temperature unit.
This is Mission Control Houston. Our mechanical systems operator here in Houston confirms that the mechanical power has been turned on, and we're standing by for release of the Perlas. Telemetry here in Houston indicating that latches 1 and 2 on the port side of the vehicle have been released. We're standing by to watch latch number 4, which is on the starboard side, the single attach point on that side, go to release as well.
Discovery, we see the Perlas in progress. We'll be handing over to Tidris here in a minute.
Roger that, Story.
This is Mission Control Houston. We've had a short dropout of data as ground team transitions communication from the western satellite to the east. Just before going into that short dropout, we saw latch assembly number 4 going to release, and we've reacquired now through the east satellite and have confirmation that in fact latch number 4, the single starboard attach point, has been released. We're standing by now for the release of the 4th and final latch assembly, latch number 3, which is the keel position below the telescope at the bottom of the payload bay. And with acquisition of the tracking and data relay satellite east, we can expect to take some live television from Discovery as the Perla release sequence is completed. The umbilical dead-faced and disconnected after the transferred internal power, and then the final lifting of the Hubble Space Telescope from Discovery's payload bay. Mechanical Systems Officer here in Houston confirms that all of the payload retention latch assemblies have been released, and the telescope is now free of the structural attach points, and we're standing by to watch the transfer to internal power.
And Houston Discovery, we interpret that we're still go for transfer to internal power.
That's firm, Lauren.
That'll be in work.
Thank you.
And so precisely one day after lifting off of Launch Pad 39B at the Kennedy Space Center, the Hubble Space Telescope is ready to fly on its own internal power and be lifted from the payload bay of the Discovery. This live view looking down the port longeron from the forward bulkhead position. The yellow and black striped protrusions along the longeron in the middle and foreground of the field of view are the guide bars up through which the attach points of the Hubble Space Telescope will rise as mission specialist Steve Hawley begins to lift the telescope from the bay. And we're standing by for confirmation of transfer to internal power.
And Houston Discovery, the transfer to internal power is complete. The MET of main bus power, internal power on was 1 day, 0 hours, 2 minutes, and 30 seconds.
Thank you, Lauren.
And with that transfer to internal power beginning at 1 day, 2 minutes and 30 seconds, we anticipate a lifetime on Hubble's internal batteries to be roughly 8 hours, providing ample margin for a nominal deployment of the solar arrays. With the transfer of the Hubble Space Telescope to its own internal batteries, we're...
Houston Discovery, the umbilical is dead-faced, and we'll be standing by for your go for umbilical release.
Roger, Discovery.
Lead Flight Director Bill Reeves inquiring as to stock's readiness for disconnect.
Discovery, your go for umbilical disconnect.
We copy that. Go for umbilical disconnect.
It's firm.
And Houston, don't know whether you were watching or not. The umbilicals are disconnected. There was a good, clean separation confirmed visually on TV monitors.
Thank you, Lauren.
This is Mission Control Houston. At 1 day, 7 minutes into the flight of Discovery on STS-31. Hubble is now on its own internal power, and the game has begun. The race is on, the clock is ticking with 8 hours of battery life on Hubble's internal batteries. Crew of Discovery has that much time to conclude the Hubble Space Telescope deploy operations, including observing and confirming the deployment of the solar arrays, and if necessary, venturing into the payload bay to assist in that activity. Mission specialists Kathy Sullivan and Bruce McCandless on the middeck in the final stages of preparing their suits for a quick donning and pre-breathe should their services be required.
Discovery Houston.
Discovery, go ahead.
Are you using the camcorder, Lauren? The reason we're asking is if you're not using the camcorder, we will command synchronous.
We currently are not using the camcorder.
Okay, then we'll command synchronous to get to GMT on the downlink TV.
Story, how badly do you want that? We're ready to move the telescope, and it's kind of a all hands are busy thing right now.
We'll do it from here.
Thank you, appreciate that.
This is Mission Control Houston, our live downlink television from the payload bay cameras aboard Discovery depicting the Hubble Space Telescope as it's being very deftly, very slowly lifted up out of the payload bay with the robot arm by mission specialist Steve Hawley. Flight controllers here in Houston watching the rates on the RMS via telemetry through the tracking and data relay satellite system, reporting that the rates look good. The first maneuver in the unberthing and preparation for solar array deploy of the Hubble Space Telescope will be a maneuver to a low hover position, which is essentially in the same coordinate position that it is in the payload bay, but some foot or so above the payload bay longerons. At that point, mission specialist Steve Hawley will load new targets into the remote manipulator system computers and drive it to a high hover position, roll it in, and begin the pitch around to place it in the proper configuration for solar array deployment. In this solar array deploy attitude that Discovery is in at the time, which has the sun constantly off the nose of the orbiter Discovery. We're getting some reflection of the sun off of the aperture door of the Hubble Space Telescope as Hawley continues to lift it slowly out of the payload bay. The image in the majority of the field of view is reflection of the forward bulkhead in the metallic aperture door of the telescope. Flight controllers continuing to watch via telemetry the very subtle, discrete rates on the remote manipulator system as it continues to drive Hubble out of the bay. Everything continuing to look very good. And as Hubble is being lifted out of the payload bay, the orbiter Discovery at the top of the ascending node of orbit 16, beginning to pass over the Cape Canaveral Kennedy Space Center area from whence it came yesterday morning, just about 1 day, 15 minutes ago. The telescope is now roughly 3/4 of the way to the low hover position. The robot arm continuing to drive continuously and slowly. This is Mission Control Houston. We're continuing to take live downlink television from the payload bay cameras aboard Discovery as mission specialist Steve Hawley continues to drive the remote manipulator system to place the Hubble Space Telescope at its low hover position, which is a position adjacent to that it held in the payload bay, but some several feet above the payload bay longerons. Flight controllers here in Houston continuing to watch the robot arm joint motion and rates. Everything continuing to look very good. And we anticipate the telescope reaching that low hover position in just a matter of a few minutes. This is Mission Control Houston. PDRS officer here in the flight control room confirming that for all practical purposes the telescope is in the low hover position, and mission specialist Steve Hawley just doing some minor tweaking to adjust its posture above the payload bay. The next RMS maneuver after some commanding from the stock will be the transition to a 90-degree roll position, followed by the move to high hover.
Discovery, we see you at low hover. No need to acknowledge. We are commanding the DCE, MCU command groups.
Roger that.
This is Hubble Telescope Control, Greenbelt, 1 day, 31 minutes mission elapsed time. The orbital verification team is right now in the process of taking the first step toward deploying the Hubble's two 40-foot long, 8-foot wide solar arrays. The team is sending commands to power up the deployment control electronics aboard the spacecraft. This is an internally redundant black box that controls the deployment and retraction of the solar array wings and monitors the status of the deployment mechanisms as that activity is underway. Specifically, it monitors such things as deployment motor temperatures and solar array blanket tension. The secondary deployment motor temperatures must be at least 32 degrees Fahrenheit and not more than 78 degrees Fahrenheit prior to starting a deployment. Additionally, tension on the wings should not exceed 10 pounds during deployment. There are two methods should there be a problem with excess tension on the wing to stop deployment. It can be stopped from here in the control center should that become necessary. Additionally, the crew has the capability on board the orbiter to visually monitor the tension and stop deployment. Orbital verification team in the process of sending those commands. It's a three-step process, and it'll take approximately 5 minutes to complete the first set of commands to turn on the deployment control electronics. Once that's completed, the team will begin commanding the configuration of the mechanisms control unit. This also internally redundant electronics which actually control the motors, the latches, and the hinges for the solar arrays, high gain antennas, and the aperture door. Things looking good as we continue to step through this process of activating the deployment control electronics. Meanwhile, we're continuing to receive downlink television of the Hubble telescope at the end of the remote manipulator arm. Visible is the underside of the telescope for the first time, and to the right of the field of view is the starboard solar array wing in its stowed configuration running parallel to the light shield on the telescope.
Discovery.
Go ahead, Charlie.
Story, we're up to the point of the Biomed and UHF comm checks with the EV guys, but what we'd like to do, provided EV concurs, is we'd like to hold until we get the telescope up to one of the long-standing positions, and then we'll get that in, and that I think that way we won't be working too many things at once.
EVA says that's fine, Charlie.
Okay, thank you.
And this is Hubble Telescope Control. The orbital verification team has confirmed that sequence 20, activation of the deployment control electronics, was successful. And they are proceeding with the first step in the next sequence, which is to configure the mechanism control unit. Those commands now on the way to the spacecraft. The mechanisms control unit is kept off until the telescope has been placed in a low hover position by the mission specialist, Steve Hawley, and this is done to prevent the premature deployment or inadvertent deployment of the appendages while the vehicle is in the payload bay. Orbital verification team continuing to step through activation of the mechanisms control unit without any problems. It's going very smoothly at this time. Continuing to receive downlink television of the telescope in the low hover position. The most of the yellow rails running both along the and across the axis of the telescope are handrails. They are crew EVA rails that would be used should the crew need to do an EVA during deployment, and also during servicing missions, which are scheduled periodically throughout the 15-year life of the Hubble telescope. Also visible in the field of view is the second high-gain antenna, through which high-rate science data will be passed to TDRS, to White Sands, and on to the Space Telescope Operations and Control Center and the Space Telescope Science Institute once the telescope science instruments have been activated. For reference, we're looking at what is normally would be considered the top of the telescope, the hinged. It's the side of the telescope where the aperture door is hinged, and visible in the top of the field of view is the hinge mechanism for the telescope.
This is Mission Control Houston. As indicated by live television downlink and telemetry watched here in the flight control room in Houston, Mission Specialist Steve Hawley has begun to very slowly roll the Hubble Space Telescope along its longitudinal axis to set up the maneuver to high hover. The 90-degree roll will do a couple of things. It will protect the fixed head star trackers. It will produce a more favorable position in relation to the robot arm for the move to high hover, and will set the proper axes for pitching the aperture door end of the telescope down into the payload bay and around to the solar array deploy position.
This is Hubble Telescope Control Greenbelt as Steve Hawley continues to work with the positioning of the Hubble telescope. The orbital verification control team here in Greenbelt is sending a series of commands to switch the solar array secondary deployment motor heaters off. Those heaters were turned on a little bit less than an hour ago in the blind. Now that we are able to monitor temperatures, we have an indication that the temperatures of the motors are slightly above the 25 degrees centigrade or 78 degrees Fahrenheit. So we're going ahead and switching those heaters back off at this time. Those commands are now being sent to the telescope. Otherwise, everything going very smoothly here at the Space Telescope Control Center. Things about to get very busy once the crew of Space Shuttle places the telescope in the appendage deploy position. As next couple of hours, there will be numerous commands sent to begin deploying the arrays and the high-gain antennas and preparing the telescope for release. At 1 day, 43 minutes mission elapsed time, this is Hubble Telescope Control, Greenbelt. And this is Hubble Telescope Control, Greenbelt. The Director of Orbital Verifications has advised Payloads Officer Nellie Carr in Mission Control that we have successfully reconfigured our secondary deployment motor heaters to the off position. And we're now standing by for notification from Mission Control that the telescope has been placed in the high hover position, at which time we'll begin our actual deployment of the arrays with the latch releasing, releasing the latches that hold the arrays to the side of the telescope in the stowed configuration. At 1 day, 45 minutes mission elapsed time, this is Hubble Telescope Control in Greenbelt.
This is Mission Control Houston as Discovery tracks high out over the southwestern portion of the African continent. Steve Hawley continuing to roll the Hubble Space Telescope along its longitudinal axis to a 90-degree roll position, which will set up the final sequence of maneuvering the telescope to the appendage deploy position, which will consist of first an elevation of the telescope to the high hover position, followed by a pitch around of the aperture door end of the telescope down towards the payload bay and then aft towards the OMS pods. Once in that position, the telescope operators in Greenbelt will be given a go to begin driving the mechanisms on the telescope. During those mechanical sequences, the crew aboard Discovery will take the digital autopilot, which controls the attitude of the vehicle in orbit, to free drift, allowing Discovery to drift without reaction control system thrusters firing in order to avoid any perturbations on the appendages as they're being driven. Once the appendages are locked into position and the control team here has confirmation from the stock that that's been accomplished, then Commander Lawrence Shriver will then tweak the attitude back to the desired solar inertial attitude, and then give a go for continued mechanical sequences going back to free drift. That sequence will repeat itself a number of times while the telescope operators drive those arrays and appendages into place. But at this time, we're watching as Hawley continues the roll maneuver on the telescope, setting up the final stages of positioning for the appendage deploy sequence. Discovery now just about 16 minutes away from tracking into darkness, and just a couple of minutes very shortly thereafter passing out of range of the tracking and data relay satellite east for a short loss of signal period of about 4.5–5 minutes. Again, all systems aboard Discovery continuing to perform very well in support of nominal deploy operations today. Flight controllers here on the ground continuing to watch joint motion and RMS drive rates, and everything continuing to look very nominal as far as RMS operations go. We'll continue to take continuous live downlink television through the Eastern Satellite KU band system throughout deploy operations today, as line of sight porting with the TDRS satellite permits. And we expect to lose this signal with loss of line of sight of the tracking and data relay satellite east about 10 minutes from now. Our next expected live downlink television will come at about 9:16 a.m. Central Time as we acquire signal again through the Eastern Satellite on orbit 17. Again, Hubble Space Telescope deploy operations continue to progress without problem. At mission elapsed time 1 day and 50 minutes. This is Mission Control.
Discovery, we're about 2 minutes from TDRS LOS. Pick you up in about 6 minutes. 1 hour and 4 minutes. We see you on the way to high hover.
That's firm, Houston, on the way to high hover.
Okay, Lauren.
This is Mission Control Houston. We're just about a minute away from passing out of range of the tracking and data relay satellite east, and as we do so, Discovery and its Hubble Space Telescope beginning to pass from day into darkness. Mission Specialist Steve Hawley has succeeded in rolling the Hubble Space Telescope 90 degrees around its longitudinal axis, is in the process right now of elevating the telescope position to a high hover. Again, that's adjacent to the low hover position, but several feet higher to allow for clearance of the telescope when he begins the pitch down maneuver to pitch the aperture door end of the telescope down towards the payload bay and then back towards the OMS pods, which will set the stage for solar array deployment. After a short loss of signal period of about 4.5–5 minutes, we'll acquire again through the Western satellite. Again, we don't expect to see any more live downlink television until about 16 minutes after the hour, 9:16 Central Time. And until then, we'll be continuing to watch live telemetry from the vehicle as Hawley continues RMS operations to place the telescope in the proper solar array deploy position. At 1 day, 59 minutes, this is Mission Control.
This is Hubble Telescope Control Greenbelt, 1 day, 1 hour, 1 minute mission elapsed time. The orbital verification control team here in the mission operations room is postured to begin deployment of the solar arrays, which will begin with releasing latch mechanisms that hold the solar arrays in their stowed position along the side of the Hubble telescope during launch, followed by activation of motors which will drive the masts to which the solar arrays are attached out perpendicular to the telescope. And then the commands will be given to begin unfurling the array blankets one at a time. This is a very high activity period here at the Goddard control facility, and the Lockheed control team has a double shift on for this critical period. Shift supervisor for the deployment period is Pete Patero, and he is also assisted by shift supervisor Harry Wynn. The control team is responsible to the on-duty Goddard mission operations manager during this period of time, who is Dick Moore. And commands will be built and actually sent to the spacecraft by Ops Controller Larry Williams and Ops Controller Tim Perry. Again, all is in ready here in the Hubble Space Telescope Operations Control Center, Greenbelt, Maryland, to begin sending critical commands to the telescope to begin deploying the solar arrays, and then later the high-gain antennas in preparation for today's release of NASA's Hubble telescope. 1 day, 1 hour, 4 minutes mission elapsed time. This is Hubble Telescope Control in Greenbelt.
Discovery, we're back with you.
Roger, Houston, loud and clear.
The same, Kathy.
This is Mission Control Houston. Mission Specialist Steve Hawley has successfully maneuvered the Hubble Space Telescope to the high hover position, as it at this time beginning to tweak the alignment of the telescope in preparation for the 90-degree pitch that'll point the aperture door end of the telescope directly into the payload bay before continuing on to the solar array deploy attitude. Again, all systems aboard Discovery continuing to perform very well. We're pressing on with a nominal Flight Day 2 deploy timeline, and telemetry seen here in the flight control room already beginning to indicate that Hawley has begun the 90-degree pitch around maneuver.
And this is Hubble Telescope Control in Greenbelt. We have been given the go-ahead to begin commanding release of the forward latches, which hold the solar arrays in place during launch along the side of the telescope. The forward latches are on both sides, both the port and starboard side of the telescope are released simultaneously. The latches are operated by electric motors. Latch release is a fairly slow process. Latches are fairly beefy mechanisms, and it takes about a minute for the latches to move from the fully closed to the fully open position once the actual command to drive those motors is given. There's some preparatory commands that are sent up to do some last-minute configuration prior to actually driving those latches. Each of the solar array wings has two latches, actually, a forward and an aft latch, which are used to hold the wing stowed to the side of the telescope while it's in the payload bay. The team is in the process of sending the commands to start those motors, and we'll stand by for an indication from our telemetry here that the motors are in motion. And this is Hubble Telescope Control. We have indication that we're approximately 1 minute now from releasing the forward latches.
Discovery, we're 1 minute from releasing the solar array forward latches.
Roger, Houston, 1 minute to solar array forward latch.
Confirm, Kathy.
This is Hubble Telescope Control. We now have indication from our data here in the control room that the motors are in operation to drive the forward latches open.
Discovery, no need to acknowledge. The forward latches are in motion.
Roger, Houston, we copy.
Good news. Data indicates that both the port and starboard wing forward latches have moved to the open position. Standing by now for confirmation. And this is Hubble Telescope Control, 1 day, 1 hour, 14 minutes mission elapsed time. We have confirmation now that the forward latches are indeed open.
Discovery, the SA forward latches are released.
We copy, story, forward latches are released.
Confirm, Kathy.
And this is Hubble Telescope Control. The next commands that will be sent from the control center here will be to release the aft latches. We will need to be in a free drift configuration when this is done, because these are the primary load-bearing latches, and there is a desire not to have the reaction control system enabled because there would be a concern that perhaps loads induced into the latches, should that system fire, might cause problems with the telescope aft latches. Therefore, prior to doing that, we will wait for the crew to ensure that we are in a free drift configuration. 1 day, 1 hour, 16 minutes mission elapsed time. This is Hubble Telescope Control, Greenbelt.
This is Mission Control Houston. Mission elapsed time 1 day, 1 hour, 17 minutes. Mission Specialist Steve Hawley has driven the remote manipulator system to position the Hubble Space Telescope now in the 90-degree pitch position, with the aperture door end of the telescope pointing directly down into the payload bay. After reloading some targets into the robot arm computer, Hawley will drive it on to the solar array deploy position, which roughly points the aperture door end of the telescope towards the OMS pods, the aft end of the vehicle. And we're continuing to watch on NASA Select Television live digitally generated animation based on real-time telemetry from Discovery in orbit, although the tracking and data relay satellite West has KU support available for this period of the flight. Due to the solar inertial attitude that the vehicle is in at this point, we have KU band blockage and are unable to bring that television in. So until we acquire live television again in about 35 or 40 minutes through the western or the eastern satellite, we'll continue to look at this animation, which is modeled based on, again, real-time telemetry from the orbiter Discovery. Once the telescope is placed in the solar array deploy attitude or position, the next step will be, of course, to confirm the readiness of the telescope operators to begin the mechanical sequences, releasing the aft latch and deploying the solar array mast. Once that confirmation is given, the crew will be given a go to take Discovery to free drift, and again, to avoid any perturbations or effect on the telescope that might come from digital autopilot firings of the reaction control system on board the vehicle. While the orbiter is in free drift, we expect it to drift at a very limited rate, very slowly out of its solar inertial attitude. And once the mechanical sequence is accomplished and confirmed by the stock, Shriver will be given the go to go ahead and tweak that attitude back up. And we'll repeat that process several times until both masts and solar arrays have been deployed and unfurled, and then maneuver to the appendage deploy attitude for driving the high gain antennas into their deploy position. This is Mission Control Houston. The PDRS officer here in the flight control room watching telemetry on the ground confirms that Hubble Space Telescope is now in the solar array deploy position. Standing by for a coordination with the crew and with the telescope operators in Greenbelt, Maryland, to begin the free drift and mechanical sequences.
Houston Discovery telescope is at the appendage or solar array deploy attitude.
We see that too. Thank you, Lauren. We will be getting commands together to enable DCE motor group 5.
This is Hubble Telescope Control Greenbelt. 1 day, 1 hour, 25 minutes mission elapsed time. Shift Supervisor Pete Patero has just confirmed that the operations team is ready to begin commanding the aft latches, holding the solar arrays to the side of the telescope to the open position. And this is Hubble Telescope Control Greenbelt. 1 day, 1 hour, 28 minutes mission elapsed time. The orbital verification team has begun loading the commands and sending commands to the telescope to open the aft latches. The initial commands that are going forward are configuration commands, and once we get to the point where we're actually sending the commands to drive the motors which operate the aft latches, then the Director of Orbital Verification will advise Houston payloads that we're ready for the crew to place the orbiter in free drift. Again, initial preparatory commanding is now underway to open the aft latches and the final set of latches that hold the solar arrays to the side of the telescope.
Discovery, go free drift for solar array aft latch release in about 15 seconds.
Roger, free drift.
It's affirmed.
Free drift is there.
Thank you.
And this is Hubble Telescope Control Greenbelt. We're standing by now with that call from Story Musgrave to the crew to begin commanding the motors open as soon as the vehicle is in free drift. And this is Hubble Telescope Control. We have confirmation from the orbital verification team that the motors driving the aft solar array latches to the open position are operating.
Discovery, while you're in free drift, we'll be pressing right along for PDM deploy. We'll give you a call a minute prior to expected deploy.
Okay, Story, thank you.
In Discovery, your aft latches are moving.
And this is Hubble Telescope Control Greenbelt. We're receiving initial telemetry that shows that both the primary, or correction, the starboard and port solar array wing aft latches are in the open position. Latches open at 1 day, 1 hour, 32.5 minutes mission elapsed time. With the release of those latches, the solar array's primary deployment mechanism is free from the side of the telescope. Our next step will be to drive motors that will swing the deployment masts away from the side of the telescope to a position that's perpendicular to the telescope.
Discovery, the solar array aft latches are released. We're pressing on with PDM deploy.
We copy.
Discovery, could you go auto Verns? We're not going to command here until we get Tedra's handover.
Roger, we'll go back auto Vern.
Thank you.
This is Mission Control Houston. As Discovery has been in free drift for the last several minutes, awaiting the beginning of the deployment of the solar array masts. Discovery has drifted somewhat out of attitude, and with a handover from the tracking and data relay satellite west to the eastern satellite in just a few minutes.
And Discovery, we'd like free drift now.
Roger that. You got a pretty good roll rate going in negative direction.
Yeah, you can stop the roll
And
rate.
we're going free drift now. And storage, you copy, we're free drift.
That's a firm, Lauren, and you might use some attitude maintenance to stop the rate and then go free drift.
Roger that.
This is Mission Control Houston. In order to avoid dropout in continuous live telemetry during the mass deploy sequence, decision was made to hold off on starting that mechanical sequence until after the TDRS handover is accomplished. In the meantime, Commander Lauren Shriver tweaking up the attitude a little bit to correct for some of the drift that's already been imparted in the vehicle's attitude while it's been in free drift, waiting that command sequence for the last several minutes. In just a few minutes, we'll also be handing the satellite over to the Vandenberg tracking station and the Merritt Island station in Florida to bring some real-time television to Houston from the Space Shuttle Discovery. That will result in some non-standard signals broadcast on the NASA Select television transponder F2R transponder 13. Shortly after we've accomplished that downlink video transfer from the vehicle to Houston, we'll be back on the satellite with NASA Select and taking live KU band coverage through the TDRS system. Guidance and Navigation Officer here in the control room confirming that we're back in an attitude close to that we desire before going free drift and continuing with the mechanical sequences. And we're standing by for S-band audio, air-to-ground audio handover from the west satellite to the east, and a television handover to Vandenberg Station. At 1 day, 1 hour, 42 minutes, this is Mission Control.
This is Hubble Telescope Control Greenbelt, 1 day, 1 hour, 43 minutes mission elapsed time. As we're standing by to receive some non-standard television from the spacecraft. Here in the Space Telescope Operations Control Center, the orbital verification team is loading the initial commands, which will begin primary deployment of the solar arrays. That activity will swing the solar array masts, the masts to which the arrays are attached, out 90 degrees perpendicular to the telescope. And this is Hubble Telescope Control in Greenbelt. We are now receiving television, non-standard television, from the spacecraft of the Hubble telescope at the end of the remote manipulator system. Clearly in the field of view is one of the two solar array packages, still in the stowed position with both latches released.
Discovery will take this attitude right here. I'd like you to go free drift for PDM deploy.
Roger, free drift.
Shift Supervisor Pete Patero has given the go-ahead to begin loading and sending those commands to the telescope to begin primary deployment mechanism activity.
Houston Discovery, we're watching the solar arrays, and we recognize that they move very slowly. Has motion started yet?
And Bruce, we just sent the commands now. It'll be about 1 minute to motion.
Roger, story, thank you. Houston Discovery, we see movement on the primary deployment mechanism.
Thank you, Lauren.
And this is Hubble Telescope Control, Greenbelt. 1 day, 1 hour, 52 minutes mission elapsed time. Mission specialist Bruce McCandless has advised that they are seeing movement of the primary deployment mechanism. This motion will swing the 15-foot masts away from the side of the telescope.
And Houston, we still see good motion on the primary deployment.
Thank you, Lauren. And we've got the TV down here.
Okay, good.
This is Hubble Telescope Control, Greenbelt. 1 day, 1 hour, 54 minutes mission elapsed time. Continuing to receive television through the Vandenberg tracking station, and it is clearly showing the deployment of the solar array masts with the solar array package in the stowed position. The arrays are wound much like a pair of window shades around a roller, and kept in that configuration for launch. And once the primary deployment activity has been completed, the crew tweaks the attitude and replaces the vehicle in free drift. The operations team here will begin commanding the solar array blankets to unfurl. The solar array masts are deployed simultaneously, both the port and starboard masts, and in the field of view is the port solar array mast being deployed. The actual blankets, however, are unfurled one set of blankets at a time. The first set is the starboard, followed by the port blankets. The solar array masts are attached to the vehicle just below, or actually above, the equipment section of the optical telescope assembly. This houses the electronics packages for the telescope's optics, and directly in front of the arrays are attached directly in front of the equipment section for the telescope support systems module, which houses the other electronics for the spacecraft.
This is Mission Control Houston. At 1 day, 1 hour, 57 minutes, we're now taking live downlink television from the payload bay cameras aboard Discovery through the Merritt Island station in Florida, and again simulcasting live on Satcom F2R with NASA Select Television. We're in the process of watching the solar array mass deployment on board the Hubble Space Telescope. The telescope is in the solar array deploy position, and the Discovery is in a free drift attitude mode, which allows it to drift slightly off of the desired orbiter attitude while those mechanical sequences are in progress. With mechanical sequences complete, Commander Lawrence Shriver will be given a go ahead and tweak the attitude back up before continuing on with the mechanical sequences to follow. Again, all systems performing very well. No issues being pursued in the flight control room here in Houston. Although we're just about 30 minutes behind the planned timeline for the array and appendage deployment sequences today, there's still no reason to expect yet that we will not be able to deploy on time as scheduled on orbit 19 this afternoon about 1 o'clock. Timeliners and telescope commanders looking at their command plans, and there are opportunities between now and deploy time to cinch things up and get ahead.
It looks like motion has stopped, and it looks like it's out.
Thank you, Lauren. We'll give you a confirmation when we get it.
This is Hubble Telescope Control, Greenbelt. 1 day, 2 hours, 1 minute mission elapsed time. We're standing by now for telemetry confirmation that both of the solar array masts are fully deployed. We're anticipating that momentarily.
And Discovery, let us know if you need attitude maintenance.
We will, Lauren.
Prior to that.
As soon as we get confirmation of PDM deploy, we'll recover the attitude using auto burns, but not yet.
Roger, Story. And Story, on if you're looking at A camera, there's a phenomenal view of Florida behind the HST.
We've been watching it, Steve. Terrific. Hubble's a beautiful sight with that background.
This is Mission Control Houston. We've lost our downlink television signal through the Merritt Island station in Florida, and as Discovery has been drifting slowly out of attitude during this solar array mass deployment sequence, we have drifted into KU band blockage. So as soon as this mass deploy sequence is confirmed to be completed, we can have Commander Lawrence Shriver tweak Discovery's attitude and regain line of sight pointing with a TDRA satellite and regain that television picture. In the meantime, flight controllers here in Houston standing by for a confirmation from the telescope operators in Greenbelt that as to the status of the solar array mass deployment before pressing on in the sequence. At 1 day, 2 hours, 7 minutes, this is Mission Control.
This is Hubble Telescope's Control, Greenbelt at 1 day, 2 hours, 9 minutes mission elapsed time. We are not receiving indications yet that the solar array mast have fully deployed. The crew indicated visually that they appear to be fully deployed. We have one indication at this time that we have reached the deployment position, and the analysts here are taking a look to determine if in fact we are at this point fully deployed with the primary deployment mechanism, the two 15-foot solar array masts. And this is Hubble Telescope Control in Greenbelt. Because we're not receiving full deploy indication on the primary deployment mechanisms, the control team here in the Space Telescope Operations Control Center is in the process of sending some alternate commands to the telescope. This is a procedure that was designed pre-flight to deal with just such a situation. This will take us a few minutes at T-minus correction at mission elapsed time, 1 day, 2 hours, 11 minutes. This is Hubble Telescope Control, Greenbelt.
In Discovery, we do not have confirmation that the PDMs are deployed. We'll get back with you.
Story, we understood you to say negative confirmation on PDM deploy, is that correct?
That's affirmed. On the plus side, we have neither the primary or the redundant indications of deploy. On the negative side, we have the primary but not the redundant.
Okay, we copy that. We're standing by.
And we're sending some commands right now to drive with both motors.
Roger, we copy.
Discovery, in order to preserve an orbit 20 release, we'd like you to get into EVA prep.
Okay, we're proceeding with that.
Thank you.
This is Mission Control Houston at mission elapsed time, 1 day, 2 hours, 14 minutes, while Space Telescope operators in Maryland continue to troubleshoot the lack of confirmation of the solar array mass deploy. Flight controllers here in Houston have been assessing the time impact on EVA options for potential support of the deploy operation today, and determined that in order to preserve EVA support capability for an orbit 20 deploy, that the two EVA crew members, Kathy Sullivan and Bruce McCandless, ought to press on into the EVA prep timeline and begin donning the suits. Should the situation be resolved, they can be stopped in that activity until we need them to proceed any further.
Discovery, you can go. Auto Vern, we've got primary indications that both PDMs are deployed.
Okay, that's good. We're going primary Verns and auto control.
Okay, Lawrence.
Let's make that auto vernier control.
That's firm. It'll take you about 15 minutes to get back.
Roger that.
This is Mission Control Houston. That last air-to-ground exchange between Capcom Story Musgrave and
EVA
Discovery.
guys are getting set up for biomed comm checks.
EVA copies that.
And Crew Commander Lauren Shriver confirming that the stock team has seen a good indication that the masts are locked, and Shriver has given the go to go ahead and tweak the attitude. He'll be selecting auto Vern control to the digital autopilot and take about 15 minutes to get back into attitude to proceed with the deployment of the solar array wings. In the meantime, mission specialists Kathy Sullivan and Bruce McCandless will continue into their EVA preparations in order to preserve the opportunity to support an orbit 20 deploy with potential EVA support. As Shriver begins to maneuver Discovery back into attitude, we expect to reacquire line of sight pointing with the tracking and data relay satellite east, and thus our KU band TV signal, and within the next 10 to 15 minutes.
And Houston Discovery, just for your information, fire the verniers in the auto control mode, we see very, very, very minor movement at the end of the solar array boom. So it is just not hardly visible at all.
Thank you, Lauren.
This is Hubble Telescope Control Greenbelt at 1 day, 2 hours, 19 minutes mission elapsed time. As Capcom Story Musgrave reported to the crew a short time ago, we do see now that both of our solar array masts are fully deployed. What occurred here in the control room was that the orbital verification team called up a
Discovery.
Go ahead, Charlie.
Okay, Story, we've got them done in the comm carriers, and I'm going to reconfigure the biomed channels in about 3 minutes. I'll be ready for a radio check with your initiation.
Okay.
And you should be getting biomed now.
Go check.
And Story, you can go ahead and try it. I'm upstairs. I think they're dressed.
Okay. EVA crew, how do you read Houston?
Hey, Charlie, I heard the first word or two of Story's transmission, and then he dropped out.
And we're hearing you loud and clear,
let me get
Bruce.
Try it again. And Houston, give them one more try.
And Bruce, Houston's reading you loud and clear.
Okay, I read the words loud and clear, but only those words.
Okay, Bruce. And Kathy, Houston.
Sorry, EV1, why don't you try again, please?
Okay, Bruce, Houston. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
I'm getting you about 50% of the time, Story. I got the Bruce Houston, and then I got 4, 5, and then something else.
And Houston from EV2, that's not an EV1 problem. It's common to the link. I'm hearing the transmissions the same.
All right, thank you, Kathy. I'll give you another count. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Okay, Story, I copied 1, 4, 5, and then 1 counting down again. I heard you on the mid-deck speaker for the intervening numbers.
Okay.
And for your info, Story, both EMUs are in PTT at this time.
Thank you. If you want any further counts, let me know.
I hear your transmission intermittently, Story. I'd have to assess that we've got about a 50% copy rate from you.
Okay, and is the orbiter crew getting me all the time?
Yeah, I can hear it on the mid-deck speaker even when you cut out on the EVA comm.
And that's affirmative, Story. We're getting both EV crewmen and Houston 5 by, although you are considerably weaker than they.
Okay.
And Story, EV2 still didn't copy anything from you about biomed. Do you verify biomed?
Stand by 1.
This is Mission Control Houston, underway at this time. Our EVA communications checks using the communications gear that will be used by the EVA crew members once they're in their suits. And we're standing by for some tweaking and reconfiguration of some ground equipment that affects the uplink voice before trying those comm checks again. Again, mission specialists Kathy Sullivan and Bruce McCandless are pressing on into the EVA preparation procedures in order to preserve the option for EVA support of deploy operations today due to the lag in the timeline. We're now taking live downlink television through the Tracking and Data Relay Satellite East KU band system. And the limb of the Earth coming into the right portion of the field of view as Commander Lauren Shriver continues to maneuver Discovery back to the preferred solar array deploy attitude. And Discovery now on the descending node of orbit 17 just off the South Atlantic coast of Africa. Again, we're standing by for some reconfiguration of some ground communications equipment before reattempting communications checks with the EVA crew members via their EVA comsets in the middeck of Discovery.
And we'd like to do another comm check with EVA crew. 1, 2, 3, 4, 5. 5, 4, 3, 2, 1.
Hey, Troy, that sounded a little better, although the first words, I'd like to do another comm check with the EVA crewman, came only over the middeck speaker. They did not come over the RF link to us.
Okay, Bruce.
And Story, any luck on the biomed?
We do not have it yet. I'll check again. Charlie, we still do not have biomed.
Bad Story, I guess unless you guys think you're going to find something here in the next few minutes, we're thinking that perhaps we ought to just go ahead and terminate the checks and so we can get off the get the units back off.
Houston for Charlie.
Go ahead, Story.
The only suggestions we got are to, cycle the connections, the pigtails on your signal conditioners. We have no other ideas.
Okay, I'll have them do that one more time. And I'll go up and recycle the biomed channel selectors.
Yeah, and it's not likely we wouldn't be getting both of them, but that's the only suggestion we have.
Okay, Houston, we've completed the cycle on the biomed channel selects, and I think Bruce and Kathy have completed disconnect and reconnect on the pigtails.
Copy, Charlie.
Houston, that's close to correct. EV2 is now hooked back up. EV1 is in work.
Okay, Kathy.
Okay, Story, I'm back online. I have disengaged and re-engaged each of the three connectors in the biomed loop.
Discovery, we still have no biomed from either crew member. I think you've done all you can.
This is Mission Control Houston at 1 day, 2 hours, 33 minutes. Discovery has reacquired the solar array deploy attitude and is ready for confirmation from the telescope operators that they're ready to press on with the mechanical sequences and going back to free drift to accommodate that. Flight controllers looking at the timeline implications from the
Discovery,
delays we've encountered this morning in coordinating the mechanical sequences. And at this point, while folks are looking with a watchful eye to the possibility of an Orbit 20 release, which it would be one orbit later, planners have not yet abandoned the real possibility of making the release on time simply by moving some of the sequences and the commanding procedures up in the timeline a little bit. In the meantime, EVA crew members will continue to prepare EVA equipment for the possibility of supporting deploy operations should it become necessary. The solar array masts are in place, and at this point we'll be pressing on with attitude maintenance to support the unfurling of the arrays. Assuming that can be conducted in the time we expect, there are some good opportunities for cinching up some of the remaining commanding and still preserving an Orbit 19 release. The orbiter Discovery now crossing the terminator from day to dark to the dark side of the Earth at orbital altitude of 330 nautical miles just off the southeast coast of the African continent. We're also just about 7.5 minutes away from losing signal through the tracking and data relay satellite east. We'll have a short loss of signal period, about 4.5 minutes, before acquiring again through the western satellite. And some 20 minutes or so after that, when we move back into the lighted part of the orbit, we'll be prepared to begin the next mechanical sequence. So in the between now and then, Shriver will maintain attitude with the digital autopilot in the auto vern mode, and once we reach daylight period again and can continue with the mechanical sequences, we'll be giving Shriver the go to go back to free drift and the stock a go to command again. Still encountering some difficulties in establishing clear communications with EV crew members through their EVA communication sets, but not enough to preclude continuation of EVA preparation. So the crew is going to press ahead on the EVA preparations, and while people continue to troubleshoot the problems that we've had with voice dropouts. All systems aboard Discovery continuing to work very well in support of deploy operations. No issues being followed here in the flight control room in Houston other than looking at some timeline options to preserve the Orbit 19 release. And Lead Flight Director Bill Reeves is pulling the troops here to see if we have any messages for the crew before losing signal in just a few minutes. At 1 day, 2 hours, and 37 minutes, this is Mission Control.
Houston Discovery. Houston Discovery.
Go ahead, Charlie.
Yes, sir. Just clarification story. We're at just finished step number 19, and we wanted to know if you want us to continue on since we were kind of running behind there with the appendages.
No, you can stop right there, Charlie.
Okay, we're going to hold at step 19.
That's affirm. And all the Hubble stuff, we will pick all that up again as soon as we get daylight. In Houston for Lauren.
Go ahead, Story.
Yeah, we'd like you to interconnect left ohms to RCS. It's in orbit pocket, page 8-3.
Okay, we copy interconnect left ohms to RCS, orbit pocket.
That's firm.
Houston Discovery.
Go ahead, Lauren.
After opening the cross-sea valves, our left and right fuel manifold pressures are less than 130, and we need to check with you.
We were just about to get up with you. Your still got to go for the interconnect.
Okay, we copy.
Discovery, we're a minute to Tidris LOS. Pick you up at about 2:48.
Roger, 248, Story.
And we like your interconnect, Lauren.
Okay, thank you.
This is Hubble Telescope Control, Greenbelt, 1 day, 2 hours, 43 minutes mission elapsed time. The orbiter has passed out of range of the tracking and data relay satellite. Will reacquire in approximately 4.5 minutes. Fairly busy pass, not only in Houston, but here in the Space Telescope Operations Control Center, as well as the control team deployed the primary deployment mechanisms for the solar arrays. This activity took a bit longer than anticipated because the control team could not receive an indication that both of the masts, the 15-foot masts, were in their fully deployed position. As a result of that, there is a pre-mission procedure, alternate procedure, which was used to command those masts to the deployed position. Basically, that entailed switching from the primary to the redundant deployment control electronics box, and using the redundant electronics to command the motors to finish opening the solar arrays. This electronics is contained in the subsystems module bay number 7 on the telescope. And again, this box controls the deployment and retraction of the array wings, and also monitors the status of the deployment mechanisms. Not really known at this time whether the wings were actually, or correction, the masts were actually deployed, or whether it was just an indication problem. In any case, that SLCM, as it's called, it's an alternate procedure, was successful, and the masts are fully deployed at this time. Following that, the verification team went ahead and reconfigured the data management unit, taking it out of bypass, which was a step that was required to enable the tension test for the solar array wings. This is basically a system that monitors the tension on the blankets as they're being deployed, and should that tension exceed approximately 10 pounds, would automatically stop deployment or unfurling of the solar array blankets. Activities of the last hour or so have put the deployment of the solar arrays slightly behind schedule. The orbital verification team, analysts from Goddard, Lockheed, as well as the folks from the European Space Agency and analysts in Huntsville, Alabama, have been looking at the situation and are considering moving up some of the activities that were scheduled to occur later on into the upcoming tracking and data relay satellite pass. These activities include potentially deploying the high-gain antennas, unlatching the aperture door, and turning on the magnetic torquer electronics a bit ahead of schedule, which then would put us in a good position to preserve our Orbit 19 release of the telescope. Again, at the present time, that is still being considered, and we're anticipating decisions on that shortly. Other than being somewhat behind schedule at this time, everything otherwise is going very smoothly, and we're continuing to look toward deployment of and release of the Hubble Space Telescope today. At 1 day, 2 hours, 47 minutes mission elapsed time, this is Hubble Telescope Control in Greenbelt.
Discovery, we're back with you.
Roger, Houston, loud clear.
The same, Lauren.
This Hubble Telescope Control Greenbelt, we have confirmation that we are moving forward deployment of the high-gain antennas, and the orbital verification team is now in the process of setting up to send commands to begin that process. And this is Hubble Telescope Control. Shift Supervisor has given the go-ahead to begin sending commands to enable the high-gain antenna torque limit tests. Basically, these are triggers that would stop motion of the high-gain antenna should...
Discovery, Houston.
Go ahead, Houston.
Okay, here in the night pass, we're going to pick up with the high-gain antenna deployment, and then when we get sunrise, we'll pick up again with the SDM deployment.
Okay, we copy that. And we'll set up our TVs to watch that.
Thank you.
Capcom Story Musgrave advising the crew that the Telescope Operations Control Center is proceeding with the deployment of the high-gain antennas. First step to enable the torque limit test, which will terminate motion of the antennas should the torque limits be exceeded. Second step of that process will be to apply power to the gimbal electronics assemblies for the high-gain antennas. That will put us in a position to release the latches which are holding the high-gain antenna masts to their stowed position parallel to the Hubble telescope.
Discovery, we're starting the command sequence. It'll probably be about 10 minutes to the high-gain latches. We'll give you a heads up when we expect them to release.
Okay, Story, we copy.
Discovery, well, we got a spare moment here. I've got some entries to make in your deployed checklist, starting on page 3-4.
Okay, stand by. Okay, Story, go ahead.
Yeah, your 15-minute past nominal deploy time is 1 day, 5 hours, 41 minutes, and 2 seconds.
Okay, we copy. 1 day, 05 hours, 41 minutes, 02 seconds.
Okay, and let me, I'll give you another time there too, in case we don't make the rev I just gave you. So right underneath that, you can write another one down. That'll be 1 day, 7 hours, 18 minutes, and 0 seconds. And that one's if we do an orbit 20 release.
Okay, we copy. For orbit 20, it would be 1 day, 7 hours, 18 minutes, and 0 seconds.
That's affirmed. And I'll also give you 2 times when you're ready on page 3-7.
Go ahead.
Okay, the orbit 19 release has not changed from the execute package. That's 1 day, 5 hours, 26 minutes, and 2 seconds.
Okay, we copy. 1 day, 5 hours, 26 minutes, 02 seconds.
That's affirmed. And then the orbit 20 time will be 1 day, 7 hours, 3 minutes, and 0 seconds.
Have a copy for orbit 20, 1 day, 7 hours, 3 minutes, 0 seconds.
Okay, and I got one more thing for you on page 3-11.
Go ahead.
You might put a little note in the margin that if you lose jet LA1 or left manifold 1, that you will not have low Z capability. And the software will not downmode you. It'll still try to give you low Z. So if you lose jet LA1 or manifold left 1, you'll want to go no low Z.
Roger that, we understand.
And if you go no low Z, change that 10 pulses you have there to 7. So you'll use 7 pulses if you're no low Z.
Okay, we copy 7 pulses for no low Z.
That's affirm, and that's it.
This is Hubble Telescope Control. 1 day, 2 hours, 59 minutes mission elapsed time. Orbital verification team now in the process of sending the commands to release the latches which hold the high gain antenna to the side of the telescope. There are 2 latches which hold the antenna mast in place. Both of these latches on each of the high gain antennas are driven simultaneously, and both sets of latches are also driven by the same commands from the ground. So we should see simultaneous release of all 4 of the latches holding the high gain antennas in their stowed position here in just a few moments.
Discovery about 1 minute from high gain antenna latch release.
Okay, we copy.
And the control team has allowed the command to go forward to the telescope, which should start driving the motors to release the high gain antenna latches. This is Hubble Telescope Control. We have confirmation that the motors driving the latches are now in operation. Everything looking good so far with release of the high gain antenna latches. High gain antennas are used by the telescope to communicate science data with tracking and data relay satellite through White Sands and back to the East Coast to the Goddard Space Flight Center and Space Telescope Science Institute once the telescope becomes operational. The dishes are attached to booms which are extended from the top and the underside of the telescope. The dishes are pointed by a 2-axis gimbal system which allows the antennas or the telescope to remain in communication with the satellite even though the telescope is slewed and rotated for different observations.
Go ahead, Bruce.
Roger, for your information, the minus V3 high gain antenna swung out, about 8 inches to a foot when the latch released, oscillated about that position, and is now sitting about, I'd estimate 6 inches out from the latch engage position, and the dish is tipped towards the aperture door, maybe 20 degrees. We haven't seen any motion on the plus V3.
Thank you, Bruce.
And that report from Mission Specialist Bruce McCandless indicating that the high gain antenna, which is attached to the underside of the Hubble telescope, that's the minus V3 antenna, seemed to be under some load when the latch was released, causing the antenna to swing away from the spacecraft up to about 10 inches and then coming to rest about 6 inches from the telescope. He indicated that the other antenna, which is at the top of the telescope, did not apparently move. We have confirmation from the control team hear that the high gain antenna latches are completely released and that we are stepping forward into the procedure which will begin swinging the masts to a position perpendicular to the spacecraft.
Houston Discovery.
Go ahead, Kathy.
Okay, Story, we just saw the plus P3 high gain latch release. Very different behavior than on the minus P3. It seemed to just move smoothly and slowly away from the latch and rebound only once. And it looks like the striker bar may be within an inch or so of the capture envelope of the latch.
Thank you, Kathy.
This Hubble Telescope Control Greenbelt, 1 day, 3 hours, 9 minutes mission elapsed time. That report a few moments ago from mission specialist Kathy Sullivan indicated that the plus high gain antenna also did in fact move away from the latch slightly, and it was resting approximately an inch away from the latch. The orbital verification team is in the process now of sending the commands to begin simultaneous deployment of the two masts.
We see both high gains moving.
Thank you, Lauren.
And as Commander Lauren Shriver just confirmed what our data screens are showing here in the control center, that the motors are in operation and the two high gain antenna masts are in the process of swinging 90 degrees to the perpendicular position.
And Houston Discovery, it looks like the high gains have pretty much stopped motion now.
Thank you, Lauren. As soon as we get a confirmation, we'll call.
Thank you.
This is Hubble Telescope Control Greenbelt at 1 day, 3 hours, 18 minutes mission elapsed time. The orbital verification team has confirmed that the high gain antennas are indeed fully deployed at this time, and they are just finishing cleaning up some last commanding as part of that procedure.
Discovery, we have confirmation your high gains are deployed.
Thank you, Story.
This is Hubble Telescope Control. The orbital verification team will now be sending a series of commands to the telescope through the deployment control electronics to drive both of the primary deployment mechanism motors briefly in an attempt to ensure that we have a good solid lock on the solar array masts in the deployed position. We have all reason to believe that they are in fact fully deployed. However, there are a couple of micro switches that were indicating that the masts were not fully deployed. That was a redundant set of micro switches. And while it's believed that in fact they are, this last drive of the motors will ensure that in fact we are fully deployed. The reason that the orbital verification team has elected to do this prior to secondary deployment of the solar array blankets themselves is because should that deployment activity induce some motion into the masts, causing those relays to close, then it could stop that deployment activity. So this is a precautionary measure just to ensure that when we go ahead and deploy the blankets, that we don't accidentally or inadvertently cause that deployment activity to come to a halt.
Go ahead, Houston.
Okay, we got a proc coming to you. It's a little different than the nominal. we need to command both sets of motors that hold the PDM deployed to set both the primary and the redundant microswitches in the deploy position. If those do not stay in the deploy position, it would interrupt the deployment of the SDMs. But that's in work, and we estimate 8 or 10 minutes before going to free drift for SDM deploy.
Okay, we copy.
This Hubble Telescope Control. Capcom Story Musgrave passing information about the procedure that's now in work to the crew. As he indicated, that'll take approximately 10 minutes. The thinking here, though, is if in fact this does not cause us to see that the microswitches have set, then chances are fairly good that the activity associated with deploying the secondary blankets would not be sufficient to cause those switches to set. Thus, it's believed that there would not be any impact on the secondary blanket deployment. Again, this is just a precautionary procedure. We really have good indication that we are fully deployed.
This is Mission Control Houston. We're anticipating some live downlink television to be brought through the Vandenberg tracking station at any moment. We anticipate having a look at the state of the high-gain antennas as the Hubble Space Telescope is perched out on the end of the remote manipulator system. Discovery now on the ascending node of orbit 18, just having passed from darkness into light on that orbit. And we're standing by for confirmation from the stock that they've set their micro switches and setting the stage for free drift attitude control once again to proceed with the mechanical sequences. At this time, we're looking at 2 potential deploy opportunities in the event that we can't catch up in the timeline and accomplish the solar array deployment without further delay. There is a chance that we can make an orbit 19 deploy, which would come at 1 day, 5 hours, 41 minutes, or 1:15 p.m. Central Time. In the event that we're unable to catch that up, we'll be looking at an orbit 20 deploy opportunity at 1 day, 7 hours, 18 minutes, or 2:52 p.m. Central Time. We're now taking that live downlink television through the Vandenberg tracking station. This view from the Alpha camera, wide-angle camera located at the forward port corner of the payload bay. Discovery attitude control currently in the auto-vern mode, maintaining attitudes until the stock gives us a call that they're ready to go free drift and begin deployment of the solar blankets. We expect that to occur in the next 15 minutes or so. Again, all systems aboard Discovery continuing to perform well. There are no orbiter systems issues being tracked by the team at this point. The only issues being pursued with any vigor in the control center are timeline issues as we pursue as we progress towards one of 2 deploy options that seem most likely at this point. Again, one being a nominal deploy on Rev 19 at about 1:15 p.m. and the other coming 1 orbit late if we're unable to catch up on the timeline over the next 2 orbits. Meanwhile, in the middeck of Discovery, EVA crew members Kathy Sullivan and Bruce McCandless continuing to press on in the EVA preparations. In the event that there were problems in deploying the solar arrays, those 2 mission specialists would be in a position to pre-breathe and then venture into the payload bay to support a deploy on orbit 20. Discovery is currently at an altitude of 332 nautical miles and approaching the the Baja Peninsula, again on orbit 18. At 1 day, 3 hours, 29 minutes. This is Mission Control.
This is Hubble Telescope Control Greenbelt. The orbital verification team has not received an indication that the procedure to try and trip those 2 redundant micro switches was successful, and the team is taking a look at that to see if there are any additional impacts as a result of that.
Discovery, Houston.
Yes, sir, go ahead.
Okay, we're still working on a proc to hold the PDMs in the deployed position, but we're starting to look pretty seriously now at an orbit 20 deploy. We want to protect that with EVA and suggest you press on with EVA prep.
Okay, Story, we were just talking about that, as a matter of fact, and we'll continue.
Thank you.
This is Mission Control Houston at mission elapsed time 1 day, 3 hours, 33 minutes. Flight controllers both here in Houston and in the Telescope Operations Control Center in Greenbelt, Maryland, continuing to discuss and develop options for the release of the Hubble Space Telescope today based on a number of ways that our mechanical sequences can or may progress throughout the remainder of this morning. The only remaining opportunity for an orbit 19 deploy is at the end of the deploy window on orbit 19. Originally, the target was the opening of that deploy window on orbit 19, which was roughly 1 o'clock p.m. Central Time. Once it was determined that we were somewhat behind the timeline, a course of action was devised to deploy high-gain antennas early and cinch some other timeline activities up earlier in the process, giving us a reasonable chance at deploying towards the end of the deploy window on orbit 19 or 1:15 p.m. Central Daylight Time. It looks at this point as if that opportunity is beginning to fade as flight controllers are beginning to take more seriously the orbit 20 deploy opportunity, and with the prospects growing in favor of that option, the crew encouraged to continue in their EVA preparations in order to preserve the EVA option for the orbit 20 deploy. Lead Flight Director Bill Reeves here in Houston, calling all principal parties onto the flight loop to assess the situation at this point and agree on a course of action for entering into these solar array mechanical sequences, which require orbiter attitude maintenance and crew monitoring of the solar arrays as they come out. The crew has no telemetry insight into those arrays as they're being deployed, but they do have the opportunity to arrest the deployment of those arrays should, in the event that some development that's undesirable occur.
Discovery, Houston.
Go ahead, Houston.
Okay, due to uncertainty in the DC function resulting from PDM deploy microswitch anomalies, when we're getting ready, a proc ready to deploy the STMs, but we'd like you to hawk to really keep a close eye on STM deployment against some convenient reference. If you ever see an STM stop, we'd like you on spec 225 to do an item 2 to stop the STMs right there.
Okay, Story, do you have an estimate when you might do that? We'd like to have Bruce and Kathy on the flight deck for that.
Okay, they've got the proc about ready now. And when you see the SDM stop, at that point, do the item 2.
Okay, I think we understand. Story, we'd like a little more clarification. You're going to send the SDM commands now?
Yes, and we'll let you know when to expect that.
Roger, and then if we see anything abnormal, we do an item 2 to stop it?
But we want you to back up the solar array stop. We want you to back up that no matter what, when you see it fully deployed. So send an item 2 as soon as you see motion stopped.
Okay, we understand. As soon as we see motion stop from a full deployment, then we back it up with an item 2.
That's affirmed. And the reason is if there's any problem with the micro switches sensing full deployment, the mechanism will go ahead and start retracting.
Okay, do we understand then that if things work normally coming up here, you want us to send the stop command anyway when the arrays reach full extension?
That's affirmed, Bruce.
Okay, we copy you, and if they stop anywhere along the route, we'll also send it.
That's firm.
Gotcha.
This is Hubble Telescope Control Greenbelt at 1 day, 3 hours, 42 minutes mission elapsed time. The orbital verification team here in the Space Telescope Operations Control Center in Greenbelt is in the process of setting up to send the command that will begin deployment of the port side solar array blankets. These blankets are approximately 10 feet long, 10 feet wide and about 40 feet long when they're both fully deployed. The blankets contain about, are each populated with about 24,000 solar cells, and they provide the power for the telescope and power to recharge the telescope batteries. The wings will be deployed first on the port side, and after that is completed, then the verification team will proceed with starboard wing deployment. Because of the difficulty that was incurred in the primary deployment activity, where we only received an indication from the primary micro switches that the masts were fully deployed, and were unable to obtain a confirmation from the secondary micro switches. A decision was made as we proceed with deployment of the blankets to have the crew watch very closely that activity for a couple of reasons, but primarily such that if something unusual occurs during that deployment activity, the crew can, from the aft flight deck, stop that deployment. Additionally, the crew has been asked, since we had that earlier difficulty, to go ahead and send a redundant command from the aft flight deck once the array is fully deployed, which will ensure that deployment is stopped with the arrays fully unfurled. The reason for this is should the arrays reach their fully deployed position and not stop, they would then automatically begin refurling. And so the crew will keep a close eye on this and send commands to prevent this from occurring. And this is Hubble Telescope Control, 1 day, 3 hours, 46 minutes. The orbital verification team has elected to hold off sending the deployment commands to the port solar array until after we hand over from the until the handover from the east to west.
Discovery Houston, we're a couple minutes here from a TDRS handover. After we get on the east TDRS, then we're going to send a proc for plus SDM deploy. We'll let you know.
Okay, we copy.
And the reason that the verification team wants to hold off until we hand from west to east TDRS is to prevent any loss of commands to the spacecraft during that handover activity.
Discovery, we're back with you on TDRS East. Got a couple switch throws on R1.
Okay, go ahead.
It's O2 Tank 3, heaters A and B to auto.
O2 Tank 3, heaters A and B to auto.
That's affirmed. It's to get the O2 pressure up for the pre-breathe.
Roger.
This is Hubble Telescope Control Greenbelt. 1 day, 3 hours, 51 minutes mission elapsed time. The shift supervisor has given a go to the ops controller to begin sending commands to deploy the port side solar array blankets. The initial commands are configuring the system. And we're standing by now for the notification from the verification team that they're at the point ready to begin driving actually driving the motors, at which time mission control will be notified so that they can advise the crew that the stock is ready to go to free drift.
Discovery, go free drift for plus SDM deploy.
You're in free drift, Story.
And this is Hubble Telescope Control.
Story. Looks good so far.
It's great, Lauren.
And we see first motion. Looks good.
And as the crew just confirmed, we're seeing both blankets beginning to unfurl on the port side solar array.
So far we see good smooth motion both sides.
And we got TV down here, Lauren.
Roger that.
It'll take approximately 7 to 8 minutes for this activity to be completed. The array is driven fairly slowly.
And Story, camera B also has a picture of this.
Thank you.
The solar arrays are driven out of their cassettes by bistems, which are at each side of the array. The bistem is visible in the television being downlinked from the spacecraft at this time. It's attached at the end of the array to a spreader bar, and the spreader bar is in turn attached to the array, which literally pulls the array out of the cassette, which held it packaged during launch. When fully deployed, both of the arrays together produce about 6,000 volts, about half of which is required to operate telescope systems, and during the daylight side of the pass, the other half is used to recharge the 6 nickel hydrogen batteries. Shift Supervisor Pete Patero just checking with his control team, receiving a report that from the ground, as confirmed by the crew from orbit, the deploy activity so far is going very smoothly. We see no indications of any problems at this time.
And as you can see, Story, we've got 3 panels out.
Thanks, Lauren.
There are a total of 7 solar panel assemblies on each of the blankets, which indicates that we're just now passing the 4th panel, so we're over halfway to completion of the deployment of the port side solar array wing. We're now seeing the 5th panel being pulled from the cassette. Now clearly visible at each side of the array blanket are the bistems, which are made of a memory material. They're rolled flat in the cassette, and then as they are pulled from the cassette.
We saw it stop on its own, and then we executed item 2 immediately.
Thank you, Lauren.
And the silver mark denoting full deployment is exactly where it should be.
Thank you.
And motion was smooth and consistent throughout.
And we saw it down here.
This is Hubble Telescope Control, Greenbelt. The system on board the telescope, which monitors the tension on the solar arrays, apparently received an indication that we had in excess of the 10 pounds of tension on the array, which triggered a limit and caused the solar array to shut the motion down, bring the motors to a stop configuration.
Discovery, you can go auto vern. We're setting up for the other array.
Okay, we'll go auto vern.
It's firm.
And Story, we're pretty impressed with the stability of the solar arrays as we maneuver back into attitude too. We don't see much movement at all.
Okay, thank you, Lauren. We're looking at them from here too.
This is Mission Control Houston at mission elapsed time 1 day, 4 hours, 2 minutes. We're continuing to take live downlink television from the payload bay cameras aboard Discovery as Crew Commander Lauren Shriver maneuvers Discovery back to the solar array deploy attitude. During the time that the solar arrays were unfurling to their full extent.
That alarm was a retrip on the left Ohms tank P that's biased high.
Okay, Lauren.
During the time that the solar arrays were being unfurled to their full deploy position, Discovery was drifting slowly out of attitude, and as is evident both by telemetry here in Houston and by the picture on NASA Select television, Discovery very slowly rolling back into position and setting the stage for the deployment of the other solar array. Discovery now on the descending node of orbit 18, just having crossed over the South Atlantic coast of South America. Got just about 15 minutes prior to entering the dark side of the orbit. And indications here in the control room are that we're nearly in attitude and rates are being damped.
Charlie.
Go ahead.
Yeah, Charlie Armstrong wants me to remind you about putting some tape to cover over the LCVG boot snaps.
Okay, sorry, that's been done already.
Okay, thank you.
This is Hubble Telescope Control, Greenbelt at 1 day, 4 hours, 7 minutes mission elapsed time. with a correction to a statement that was made earlier that there are 7 panel assemblies on each wing. There are, in fact, only 5, which indicates that all 5 of those panels are deployed or nearly deployed. There is a possibility that that the tension test, that there was an indication received here that we failed a tension test, causing the deployment to stop at the same time at which the crew sent a command when they saw motion on the array stop, bringing the deployment to a halt. However, in this configuration, even with the arrays near fully deployed, when they're oriented to the sun, they will charge the provide electricity to the batteries and to systems. At the present time, the
Houston for Lauren.
Go ahead.
We'll be coming up on night here pretty soon. Could you give us some idea about how much light you need to send the stop command to the arrays?
We think we'll be able to see when the array stops and send that command after that.
You think even at nighttime you could do that?
Yes, we think we can.
Okay, thank you.
This Hubble Telescope Control Greenbelt, the orbital verification team, taking a look at the situation with this first array deployment, the deployment of the port side solar array. And prior to beginning deployment of the second array, they want to further understand exactly what configuration we're in and what conditions brought the deployment of that array to a halt. Again, the array is nearly fully deployed, and the solar cells that are exposed to sunlight can be used to provide battery charging to the 6 nickel hydrogen batteries. As part of the mechanisms associated with stopping deployment of the solar arrays, the deployment control electronics were turned off. The next step here is to turn the electronics back on so that the orbital verification team can get a look at exactly what the tensions are on that port side wing.
Discovery, your spec 76 is a camera temp on camera alpha.
Roger that.
This is Mission Control Houston. That Spec 76 message that Capcom Story Musgrave referred to was that of a indication that a camera, in fact the camera that's currently on NASA Select Television, is beginning to reach the upper temperature limits for that camera, and that the crew ought to go ahead and cycle that camera off. We're only about 7 minutes away from losing signal through the TDRS east as it is, followed by about 4.5 minutes of loss of signal. So we'll take that time to let this camera cool itself back down and then power it back up on the other side when we acquire television capability again. Again, Discovery remains in attitude hold under Vern jet control, standing by for a status from the telescope operators in Greenbelt as to the final confirmed status of the port side array, and confirmation that we can proceed with the starboard side array deployment.
And this is Hubble Telescope Control in Greenbelt. 1 day, 4 hours, 21 minutes mission elapsed time. The orbital verification team continuing to take a look at the exact status of the port solar array wing, and in the meantime, the mission operations contract team here is in the process of sending commands to turn the deployment control electronics back on, which those electronics were shut off automatically when the crew sent commands to stop wing motion when they detected that the wing had come to a stop. The deployment control electronics, when they're turned back on, will do two things. They'll allow the orbital verification team to evaluate the tension on the port solar array. Additionally, it will configure the system so that once they have confidence that they're ready to proceed, that they'll be able to begin deploying the starboard side wing. That electronics package is required for deployment of the starboard package.
Discovery, Houston.
Go ahead.
We're looking more and more like an Orbit 20 release. We'd like you to press on with the EVA prep.
Okay, we copy. We'll press on with that.
Thanks.
And this is Hubble Telescope Control. Shift Supervisor Pete Patero has confirmed that the deployment control electronics are back on, and the verification team here at Goddard, as well as the Marshall Center in Huntsville, will be taking a look at the data from the tension test.
Go ahead, Story.
Yeah, could you confirm that the solar array was fully stopped when you sent item 2?
Yes, sir. It had been stopped for well, probably 2 to 3 seconds, I guess, before we did the item 2.
Okay, that's good information. We've got to run some, we're going to power up the DCE again and run some tension tests on that panel before we go ahead with the minus SDM deploy.
Okay, we copy that, Story.
This is Hubble Telescope Control, Greenbelt, 4 hours, 1 day, 4 hours, 24 minutes.
Discovery, we're going LOS in about 2 minutes here. See you about 4:32, and we'd like you to power off camera alpha.
Okay, camera alpha's powered up, and we'll see you then.
Yes, sir.
And as Discovery moves out of the range of the tracking and data relay satellite, Director of Orbital Verification Mike Harrington has confirmed with Payloads Officer Nellie Carr in the Mission Control Center that we have the deployment control electronics back on. We have taken a look at the tension data, and all indications are good that the solar array wing is indeed fully deployed. Apparently the indications of a tension test failure came as part of the crew's procedure when they went ahead and backed up the shutdown of the motors that were driving the solar array to its open position. So at least initially we have some good news here in that solar array on the port side of the vehicle is indeed fully deployed. In the meantime, the orbital verification team is discussing moving some additional activities forward in the timeline during this night pass, which will clear the way for us to begin deploying the starboard solar array blankets once we reacquire sunlight. There is a requirement that we have sunlight on the arrays during the deployment of the blankets.
This is Mission Control Houston. Mission elapsed time 1 day, 4 hours, 27 minutes. As the team seems to lag further behind in the timeline with the deployment of the solar arrays on the Hubble Space Telescope. The Orbit 20 deploy option begins to look more and more realistic than Orbit 19. Discussion here in the flight control room has defined the window on Orbit 20 as opening at mission elapsed time 1 day, 7 hours, and 3 minutes. The last opportunity in which to deploy on Orbit 20 would be 1 day, 7 hours, and 18 minutes. So 15-minute deploy window available on Orbit 20. And yet to be accomplished before that can be done is a completion of the solar array deploys and then a maneuver of both the remote manipulator system and the orbiter vehicle to the final release attitude, which sets up the separation burn following the actual release of the telescope. All systems aboard Discovery continuing to perform very well. Discovery basically a very clean bird with the exception of the failed reaction control system primary thruster, which has been isolated, and in the course of that isolation taken out 2 other RCS thrusters, but with the redundant thrusters available, no loss of capability and no impact on continuation of deploy operations. Again, no systems issues being tracked by the flight control team here in Houston. Basically, we're keeping an eye on timelines and what options we have to work with the telescope operators in Maryland to cinch up the timeline. And while the Orbit 19 opportunity has not been entirely given away, it is beginning to look more and more like the Orbit 20 deploy opportunity is most likely. So with that window opening at about 2:37 p.m. Central Time and closing about 2:52 p.m. Central Time, Mission Specialist Kathy Sullivan and Bruce McCandless continue to work into the EVA preparations procedures to provide the EVA support option for that Orbit 20 deploy opportunity. Both McCandless and Sullivan had located themselves on the aft flight deck to observe the solar array deployment and had shortly interrupted the EVA preparations while they were doing that in order to assist in sending the command to stop the to turn off the DCE and stop the array deploy were it necessary. And they were then given a go to, or given some encouragement to get back to the mid deck and press on with the EVA preparation. So we do have that option with the Orbit 20 deploy. As of yet, there doesn't appear to be any reason or cause for concern that there would be a reason for the 2 of them to venture into the payload bay. It appears that the deployment of the plus wing was nominal, and with successful deployment of the minus wing, the mechanical sequences will have been accomplished, and it doesn't look as if there will be any continuing need to pursue EVA preparations. But one hurdle yet to go as we acquire signal again through the eastern satellite. We'll have just about 22 minutes before acquiring daylight again, and which is desirable before we begin the next mechanical sequence. And going, as Discovery is now in Verne control, holding its attitude, we've got about 20 more minutes before going to free drift and preparing for that minus array deployment. We're now taking data through the tracking and data relay satellite west and standing by for
Discovery,
voice.
we're back with you.
Loud and clear, Houston.
The same.
This is Hubble Telescope Control, Greenbelt, 1 day, 4 hours, 34 minutes mission elapsed time. Shift supervisor here in the Space Telescope Operations Control Center running through a poll of his positions to ensure that they are ready to resume commanding of the telescope, and that all of the indications from the telescope, now that we've reacquired data, are normal. And we are in a position here shortly to begin resuming commanding. We have readjusted the schedule somewhat to take advantage of the night pass, during which time we are unable to deploy the second solar array wing, and to make up some of the time that we're down, the team is going to begin by sending a series of commands that will enable the tension test on that starboard side wing. That is a necessary step that must be completed prior to beginning deployment of the wing. Again, that's the system that will stop wing motion if the tension on the blankets exceeds approximately 10 pounds during deployment. Following that, they're going to step on to go ahead and unlatch the aperture door, which was not scheduled to occur until later today. The door will not be opened. It will simply be unlocked or unlatched. And one of the reasons that we do this early is since we have the crew prepared to do an extravehicular activity should it become necessary. By unlatching the door, we can get some confidence that that latch works, and should it become a problem, then we would have an opportunity to get assistance from the EVA crew. Again, we're not planning to open the door, just simply to open the latch. Following that, the verification team will send a series of commands to turn on the telescope's magnetic sensing system power. The magnetic sensing systems consists of two 3-axis magnetometers situated on the light shield near the aperture door, and this system is used to sense the Earth's magnetic field. Readings taken of the magnetic field are compared with onboard computer models of the Earth, and this provides the telescope with a course attitude reference. The magnetic sensing system is also used in combination with the telescope's magnetic torquers, which are basically large electromagnets on the telescope. And this is used as part of the pointing and control system to both manage the momentum wheels to ensure to reduce the amount of or to reduce their speeds or avoid them from saturating. And in addition to that, it can be used, the magnetic torquers can be used to help move or position the telescope if that were required. And finally, the team hopes to complete sequence 29, which will activate the reaction wheel assemblies and the magnetic torquer electronics. As mentioned, the reaction wheel assemblies are used to position the spacecraft or change the spacecraft's attitude. And this is Hubble Telescope Control. The orbital verification team has completed activating the starboard wing tension test, and in the process of verifying that it has in fact responded the way that it should. And we have received confirmation that the tension test has been enabled, and the verification team is now beginning to step through the commands to unlatch the aperture door.
Discovery, about 1 minute to aperture door latch release.
Copy, Houston.
This is Hubble Telescope Control, 1 day, 4 hours, 42 minutes. Electrical Power System Console Operator has confirmed that he sees data indicating that the aperture door latch motor is now driving the latch open. And this is Hubble Telescope Control, Greenbelt. Initial data coming in to the Space Telescope Operations Control Center indicates that a motor drive has been completed and that the aperture door latch is now open. Standing by for confirmation. This is Hubble Telescope Control. We now have confirmation that the aperture door latch is open and that the sequence of commands is complete. Next step will be to power up the magnetic sensing system.
Discovery, your aperture door latch is open.
Copy that, Story. Thank you. And status for you, Houston. Charlie's downstairs in the process of getting Bruce and Kathy buttoned up in the suits.
EVA copies, and we're watching the fans come on.
Sorry, Story, that was broken. Say again, please.
Yeah, we're following you down here. Thanks, Steve.
Okay, very good.
Hubble Telescope Control, and as the crew continues with their activities to prepare to support the Telescope Operations Control Center with an extravehicular activity should that become necessary, the orbital verification team here continues to work to attempt to make up some of the lost time by moving forward and executing several of the commands that were not scheduled to be executed until after the second solar array blanket was deployed. This time in the process of sending commands to power up the two 3-axis magnetometers. This Hubble Telescope Control, 1 day, 4 hours, 50 minutes mission elapsed time. Orbital verification team has completed powering up the magnetic sensing system and is now proceeding with commands to turn on the reaction wheel assemblies and the magnetic torquer assemblies. Again, the magnetic torquers create a torque to help change reaction wheel speed and can also be used in course attitude adjustments if necessary without the reaction wheels. Orbital verification team stepping smartly through the power on of the reaction wheel assemblies. We have a good indication that we have power to reaction wheels 1 and 2 in the process now of powering on reaction wheel number 3. And we have a go now to power on reaction wheel number 4, waiting for a confirmation. Now receiving confirmation that we have good indications on reaction wheel number 3 and number 4. And with power on of all 4 of the telescope's reaction wheels, we have a good indication that those systems are performing nominally, no problems at this time. Moving forward now to powering up the magnetic torquer electronics. This is Hubble Telescope Control, Greenbelt. We have confirmation now that the magnetic torquer electronics have been powered up. This is Hubble Telescope Control, Greenbelt, 1 day, 5 hours, 4 minutes, mission elapsed time. The orbital verification team now proceeding with a step in sequence number 22, which would have come at the end of the minus wing deploy earlier but was postponed, and that is the enabling of the activating of the charge current controllers, which are used to cycle charging of the batteries. These controllers sense the...
Discovery, we're sending you an orbiter and target state vector.
We copy.
Be sending you a covariance matrix also.
Roger that, Troy.
The charge current controllers monitor the status of the batteries, and they initiate and terminate charging from the solar arrays. There's one charge current controller for each of the telescope's 6 nickel hydrogen batteries. And we have an indication that we are finishing up now with the activation of those charge current controllers, and we'll be taking a look at some of the currents that are indicated from the wing and the battery.
This is Mission Control Houston. In just about a minute, our NASA Select television transponder on SATCOM F2R will be handed over to the Vandenberg tracking station in order to bring some live downlink television from aboard Discovery to Houston. So NASA Select transmissions on the satellite will be shortly interrupted. Those viewers in Houston will be able to see continuous NASA Select programming, including the color-converted live downlink television. After passing through the Vandenberg station, we'll hand back to the tracking and data relay satellite and free up our transponder and be back live on SATCOM F2R.
Discovery, we're a minute into Teeter's handover. Your vectors are good.
This is Mission Control Houston. We're now configured to take live television through the Vandenberg tracking station in California, and we're standing by to take those live views from Discovery. Discovery currently in attitude hold, controlled by the digital autopilot. We're standing by for a go from the telescope operators to go to free drift, setting the stage for the deployment of the solar array.
Discovery.
Go ahead, Discovery.
Okay, Story, just a status on the EVA. We're into the EMU purge. So far, we've had no anomalies. Both suits are good, and Kathy and Bruce are right into the purge, and I'll give you a call when we start the pre-breathe.
Thank you, Charlie.
This is Hubble Telescope Control Greenbelt. 1 day, 5 hours, 12 minutes mission elapsed time. With the completion of activation of the charge current controllers, the orbital verification team is now in the process of sending preliminary commands that will deploy the starboard solar array blankets.
Discovery.
Go ahead, Charlie.
Okay, Story, do you guys have a pre-breathe time for us?
$40 minutes, Charlie. 40 minutes.
Okay, we copy. 40 minutes.
Discovery, we'd like free drift for minus SDM deploy.
Okay, we copy free drift.
It's firm.
Okay, you're in free drift now.
Thank you.
And with that confirmation that the orbiter is in free drift, the go-ahead has been given to send the commands that will actually start the motors deploying the starboard solar array wings. We're now receiving television, and we have...
Okay, we had drum lock release.
And this is Hubble Telescope Control. The crew confirmed that we had release, and we have an indication that we have stopped at this point deployment of the secondary blankets. The team here is taking a look at data to determine exactly where we are at this point. And this is Hubble Telescope.
You probably saw the drum lock release, but we have not seen any motion since then.
Thank you, Lauren. And we see the DCE off at this time.
Okay, do you want us to send item 2?
Stand by 1, Lauren. Lauren, you do not need to send the item 2. DCE is off.
Okay, we concur.
This Hubble Telescope Control, 1 day, 5 hours, 16 minutes, mission elapsed time. That conversation related to whether or not the crew needed to send an off command to stop solar array motion. They were told that that was not necessary. The initial indication, both with data and visually, was that the solar array latches released. However, we did not see any wing motion in terms of the wings actually being pulled from their cassettes. There was apparently a safe mode trigger that stopped that activity and turned off the deployment control electronics. The orbital verification team, supported by analysts here in Greenbelt and in Huntsville, are now taking a look at...
And Story, just another note, you know, the drum lock release looked the same as the plus V2 array. It looked normal. It still looks normal. It just didn't move anymore after that.
Thank you, Lauren.
And if you would, a recommendation on the DAP mode.
Okay, we'll get back with you.
Okay, sir.
A moment ago, we received observation from Commander Lawrence Shriver that he did not observe any difference between the array release on the starboard wing and the array release on the port wing, only that there was no further motion once the arrays were released. That was basically the same indication that was received here in the Space Telescope Operations Control Center. And again, the analysts, both from the European Space Agency, NASA, and others, are taking a look at that situation at this time. At mission elapsed time, 1 day, 5 hours, 19 minutes. This is Hubble Telescope Control, Greenbelt.
And Lauren, you can go back to Auto Vern.
We'll go back to auto control.
That's firm, Auto Vern.
We're there.
Houston for Charlie.
Go ahead, Story.
Charlie, what did you get for an EVA pre-breathe start time?
Okay, we started at standby 1. Let me give it to you in MET. Okay, Story, we started it at 5 hours, 17 minutes.
Thank you, Charlie.
This is Mission Control Houston. Mission elapsed time, 1 day, 5 hours, 24 minutes. And last exchange between Capcom Story Musgrave and pilot Charlie Bolden on board Discovery, confirming that the EVA pre-breathe has begun. That pre-breathe got underway just a few minutes ago at 1 day, 5 hours, 17 minutes. Required 40 minutes of pre-breathe will be conducted in order to properly condition EVA crew members Kathy Sullivan and Bruce McCandless now in their suits in the airlock for the possibility of venturing into the payload bay to assist with this final solar array deployment. Controllers here in Houston continuing to stand by as the telescope operators in Greenbelt, Maryland assess the situation and try to determine the status of their solar array deploy mechanism. In the meantime, Discovery currently in attitude hold. Digital autopilot set to automatic attitude control using the smaller RCS thrusters, the Werner jets. It would appear that the Orbit 19 deploy opportunity is no longer a possibility, as we are now entering the first part of the Orbit 19 deploy window, which closes at 1:15 Central Time. Again, the Orbit 20 deploy window opens at 2:37 p.m. Central Time, closing at 2:52 p.m. Central Time. Those are 15-minute windows that extend 7.5 minutes both prior to and after orbital noon.
Discovery, we're up with you on Tidris East. I know it's pretty clear to you, but we are gently sliding into an Orbit 20 release. 7 hours, 3 minutes.
We copy, Story.
Again, although there has been no requirement developed as of yet to conduct EVA in support of the deploy operations, mission specialists Sullivan and McCandless are in the airlock. They are in their suits, and they are in the midst of a 40-minute pre-breathe to condition their nitrogen content to support venturing into the payload bay to assist. Meanwhile, the flight deck crew standing by for their next set of marching orders. We're waiting for the folks in Maryland to understand where they are right now with their minus solar array deploy mechanism. Discovery and attitude hold. Just about to cross the equator now at the middle of Orbit 19, just off the northwest coast of the South American continent. All systems aboard Discovery working well. All quiet here in the flight control room in Houston as we are now well into the Orbit 19 deploy window, which appears to have been ruled out at this point. Mission elapsed time 1 day, 5 hours, 28 minutes. This is Mission Control.
This is Hubble Telescope Control Greenbelt. The orbital verification team has commanded the deployment control electronics back on, which will provide some data about the status of the starboard solar array wing, and the team will be taking a look at that status and evaluating exactly where we need to go from here.
In Discovery, the DCE is commanded back on.
Roger that, we copy.
Got a switch throw on L1 for somebody.
Okay, go ahead.
Your cabin's been running about 86 degrees there, so we'd like to cool it off a little bit. You can take water loop 2 bypass manual and increase until an interchanger flow on spec 88 is about 1100.
This is Hubble Telescope Control Greenbelt. 1 day, 5 hours, 32 minutes mission elapsed time. Turning on the deployment control electronics was the first step in an alternate series of commands designed to put us in a position to recover from that interrupted attempt to deploy the starboard solar array. this time, the verification team is continuing to work with configuration of the deployment control electronics. The electronics came on a couple of minutes ago, and they're in the process of configuring them before proceeding with the alternate commands for solar array deployment. And we have completed configuration of the deployment control electronics and have an indication that our tension on the solar array wing is back in bounds, which is initially good news. The engineering folks here in the control center are taking a close look at the status of the starboard wing prior to giving a commitment to proceed with another attempt to deploy that solar array. And this is Hubble Telescope Control. We're again receiving some television of the solar array wing in its partially deployed configuration. Actually, the blankets are not extended, but the wings have, or the blankets have been released. Director of Orbital Verifications has asked the payloads officer in Houston if they could have the crew perhaps give us a closer look at that wing. And this is Hubble Telescope Control, 1 day, 5 hours, 39 minutes mission elapsed time. The orbital verification team is now proceeding with an attempt to begin deployment of the starboard solar array blankets. The commands being sent at this time to the spacecraft are primarily setup commands, and we'll basically take it down to the command.
Discovery, Houston.
Go ahead, Houston.
Okay, we're getting ready to send a proc for the minus STM deploy. We'll give you a call when we get near free drift.
Roger that.
And we've proceeded down to the point where the next command will actually start some motor activity. So soon the crew will be asked to place the vehicle into free drift prior to sending of the command to actually start deployment of the blankets.
Discovery, go free drift from minus STM deploy.
Okay, free drift.
And Lauren, just like you did on the positive STM, we'd like spec 225 item 2 when you see all motion stopped.
Okay, Story, and you're in free drift.
Thank you.
And this is Hubble Telescope Control. Now that the vehicle's in free drift, orbital verification team, ops controller is in the process of sending the commands, which should start the actual unfurling of the solar array blanket. And we see the wings beginning to move.
Okay, Story, we see motion.
So do we, Lauren.
As the blankets begin deploying, the orbital verification team is watching very closely the tension being placed on those wings so far. Looking good. And we have an indication that we had an out of limits condition. The arrays have stopped their motion.
Houston, Discovery, it looks like motion stopped with just about one panel showing.
And we see that too, Lauren. The DCE is off.
Roger that.
Discovery, Houston.
Go ahead, Houston.
Could you take the CCTV and zoom in on the outboard bi-stem, close to where it joins the compensator rail?
Okay, there's the first one. That's zoomed in max we can.
Okay, we are receiving that.
Say again?
We are receiving that picture, Lauren.
And do you want to look at the other ones as well?
Yes, please, Lauren, and you can go back to auto burn.
Okay, I'm going A auto burn. We'll look at the four corners in order then.
And Lauren, does that bi-stem look normal to you?
Yes, they do, Star. We cannot see them visually yet because of the attitude the armor's got it at, but on TV it looks normal. They're about in the same position right now that the four corners were on the plus V2 array.
Okay, thanks.
And Story, it looks like all four of the compensator rails, the spreader bar at each of the corners is anywhere from 1 to 1.5 inches in from full outboard limit. So it doesn't look like anything from here at least has hung up.
Copy, Lauren.